Good morning, everyone, and welcome to the CyberMar project file and event. I'm Yoros Vasiliou. I'm a senior researcher at the Institute of Communication and Computer Systems and part of the coordination team of the CyberMar project. I want to thank all of you for connecting today to this special event for our project, which is the final event, but also the Piraeus Pilot demonstration. We are here at the PCT premises, a partner of our project, and we will start our event with a welcome note from Mr. Tassos Mavakidis, Commercial Director, Manager of PCT. Mr. Mavakidis.
Thank you very much. Welcome at PCT. I'm Tassos Mavakidis, Commercial Manager, not Director of PCT. I'm sorry I'm late. At the same time, there was some other meeting taking place. It's our great and my great pleasure to have you here and honor. Since to me, CMR project is a synonym of two major words. And these words is the synergy and the collaboration. And through this project, it has been proved that 13 partners for 8 countries, I think, with the collaboration of medium-sized enterprises and industry for research, academy, universities, and our company as an end user have been able to achieve results that you will report in this final. As you know, the consortium covers almost all different actors across not only the maritime logistics, but I think across the whole supply chain industry, and covers all the supply chain players. The attendees of this event will be able to learn more about CyberMar project, the results and the outcomes, as well as the Piraeus Port Pilot impact on the port operations. Wish you a pleasant meeting and fruitful results. Thank you very much.
Thank you, Mr. Mavakidis. Thanks a lot, and for hosting this event and having us here.
It's a pleasure and honor, I said. Yes.
Thank you.
You may
now we'll have also welcome and the introduction to the event and what we're going to see today from Mr. Eleftherios Zounoglu, also from ICCS, coordinating this project. Eleftherios, the floor is yours.
Before he starts, we wish him a happy name day, because
of course.
Name day.
Yes, yesterday. Yes.
Yesterday.
Thank you very much. It's a good way to celebrate the name day having a pilot. Afterwards,
nothing is for coincidence. You know?
We will need some time to switch between the presentations. So, Mr. Mavakidis, George, many thanks for introducing me and for having the opportunity to start this final event for this project that gradually comes to its end by the February of 2023. As George said before, this is a quite important day for the project, since we are going to have our final pilot demonstration, demonstrating what has been developed the 3.5 years of the project lifetime, as well as having a final event discussing and presenting all the different aspects of the project, as well as having the opportunity to discuss and collaborate with a quite relevant project Cybermar, the Foresight project, with which during the lifetime of the both projects we had the opportunity to closely collaborate, organize together training activities, and proving that additional to the collaboration inside the consortium, we achieved to have also quite important, interesting and fruitful collaboration with additional consortia. Some event rules that are always quite important to be mentioned, that the event is already being recorded, and this applies also for the remote participants and attendees. Please keep your microphones and cameras off, and the system will take care about this in order to ensure also the privacy issues. And you can surely provide your questions in the chat. We will have interactive discussion session at the end of the event in which all the answers will be answered and discussed. Many thanks for participation and cooperation. Now moving to the agenda of the today's event. We already started with some welcome coffee, and I have to mention that these 3 years of the Cybermar implementation was quite challenging, as it's the case also for many projects. It was also for Cybermar. We had a lot of opportunities to meet physically. We started the last months, and this is also a great opportunity. We had this opportunity during also this welcome coffee. Then we will proceed with this presentation, a really quick introduction to the Cybermar project, and then we will have an overview of the Cybermar project and the benefits that we identify with these types of solutions, proceeding to a necessary break, and then we will have a quite important part of the event, what we call the Piraeus Pilot demonstration. For remote attendees, we are in PCT premises in Piraeus port, one of the biggest commercial ports now in Europe. The scenario prepared is related to the activities to this port, as is the case also for all the pilot scenarios that we have prepared in this project. Proceeding to a lunch break, and then we will have targeted presentations, focused presentations about specific either technological components or scientific tools developed during the course of the project, meaning the macro framework on risk analysis and how impact on port operations is being calculated, the econometric model and the wider economic impacts of a cyber incident, as well as a quite important activity for the project, since at the end all the focus is to increase the cyber resilience through improved cybersecurity training, what was and still is the training program of the Cybermar project. Let me check about the question, and I hope that the question is not related to sound. We will proceed then to the exploitation of results, presentation to the exploitation of results, and how the Cybermar consortium achieved to also prepare a quite interesting, in our view, set of joint exploitation scenarios. And then, as I said before, we'll have the opportunity also to welcome Foresight project, to present also their concept, objectives and results, and have the opportunity to continue the interaction also during this meeting. Quickly proceeding to presenting the motivation of the project, going back 3 or 4 years that we we prepared a proposal in order to have this project realized. What were the main motivation behind? We know all that the maritime sector is one of the most important financial sectors in the European community, with over the 80% of goods transportation in volume to be carried by sea. And surely in this, it goes without saying that ports are key infrastructures within the logistics value chain. It's evident that during the lifetime of the project, probably also due to the pandemic situation, this has been further increased. Ports and ships are being digitized continuously at a very fast pace in order to address challenges of the globalized and competitive economy. And this leads to an increasing use of complex systems, or even system of systems, that may present many attack surfaces. And over the last decade, this has been a case in several cyber attacks, in several cyber incidents that have been noted and happened, mentioning the Antwerp port case, the port of Barcelona in 2017, the NotPetya case with Maersk, and many others that still, as you see, are being realized. And thankfully, due to efforts like CyberMar, we have the opportunity to analyze them and further develop solutions to protect the port infrastructures and in general the maritime domain against them. Main motivation and main message is that the cyber resilience of ports is essential in order to prevent possible disruptions at the end to the economic supply chain. And as you are going to see, this is the main focus and this is the main pillar, how the project has been built, and everything has been built in order to be able to measure the probability of disruption and see how this can be mitigated. Additional to that, maritime specific cybersecurity risk assessment has become essential in order to create a growing need for raising cybersecurity awareness in the maritime sector, meaning that it is clearly identified the special needs of this specific sector due to its importance, but also to its specificities when it comes to special cases, when it comes to the type of infrastructure, the type of equipment used. Now we are starting a lot, and we believe that CyberMar contributed in this to have targeted risk assessment for the maritime sector. And gradually and more, cyber ranges are recognized as efficient in order to raise cybersecurity awareness, to increase stakeholders' operational experience through training, and also to provide a valuable prevention measure through the realistic simulation of ports, IT and OT infrastructures. And this is what I was referring before. Ports, as is the case also with other industrial, let's say, environments, but ports and the maritime sector has this in a really heavy way, a combination of IT and OT, that these words are brought closer and closer, and this creates a lot of challenges, as it is going to be shown also in the scenario that we're going to demonstrate today. So the major role of a major role of the ports in the supply chain logistics has led our consortium to propose the CyberMar project, focusing, as I said before, on targeted and focused port cybersecurity awareness awareness raising and training to enhance port cybersecurity capabilities. Some quick project facts are always important to be mentioned. The full title of the project is Cyber Preparedness Actions for a Holistic Approach and Awareness in the Maritime Logistics Supply Chain. The project has been funded back in 2018 in the topic Cybersecurity Preparedness, Cyber Range Simulation and Economics by the European Commission in the framework of Horizon 2020. CyberMar is an innovation action, meaning that we always have in mind how solutions are going to be applied in the industry, and this is also supported, as I said before, by the commercialization, by the exploitation plan that has been prepared. The total cost of the project was about 7.2 million, with an EU contribution of almost 6 million euros. The coordinator of the project is the Institute of Communication and Computer Systems, for which I would like to say a few words. Actually, it's a research institute inside the National Technical University of Athens, undertaking advanced research in the field of electrical, electronic, and computer engineering and technologies. Being such an institute, as you can understand, and it is shown in the right part of the screen, a lot of activities related to computer science or electrical engineering are being held, including nowadays a lot research related to cybersecurity. As a last note from my side, although my colleague George is going to present them in detail, a summary of what we believe are the main results of the project, and we can say that we are proud about them. First of all, we developed as a consortium an innovative platform that tries to extend the capabilities of cyber ranges in order to increase cyber awareness, preparedness level, validating the business continuity management and minimizing business disruption potential of maritime logistics chain actors. Then, as a part of this extension, is an integrated learning management system for providing a cost-effective and easily accessible training environment that covers in a targeted way the needs of the maritime domain. We deployed and interconnected a cyber risk analysis tool and framework with econometric models in order to support decision-making for cybersecurity measures. And we also established collaboration with certain CSERT networks and tested also the operational ways to analyze cybersecurity data and information collected through the integration of tools that are now well accepted in the certain CSERT networks like the MISP framework. Finally, we already validated and evaluated our solution in 2 pilot cases up to now, 2 ports and one port and 1 ship simulation environment. And we hope that today we are going also to have a quite successful demonstration, a pilot use case, again in a port, combined also with a scenario in which the railway operations are being combined. Therefore, I would like to thank you very much for your attention. Ask from my colleague George to continue with moderating the event and present in detail the CyberMar overview and the results.
Thank you, Eleftherios. And we can now proceed to providing an overview, let's say, of the project, the main objectives that we have set, the main developments and results and also some benefits that we have identified for our solution. When we started the project, we have identified some challenges, and we have set some goals that we had to pursue. The first one is that the maritime information systems are designed without accounting for the cyber risk. And it is also a fact that digital infrastructure was becoming more and more essential and critical to the safety and the security of shipping and ports. Furthermore, it is important to handle cyber preparedness as a high priority aspect in the maritime domain. And it's also important to be able for organizations in the domain to be able to estimate in an accurate way the cybersecurity investment they have to do, but this is based on valid risk and econometric models. So having these challenges, we can say that the goal of CyberMar unfolded in two main directions. The first one was to establish a cyber ecosystem for preparing of cyber attacks. And the second was to estimate the impact of such attacks from a financial perspective and supporting the undertaking of prompt decisions from the stakeholders. In order to achieve these goals, I have defined 5 main objectives that we are been monitoring during the project implementation. The first one was to enhance the capabilities of cybersecurity professionals and to raise awareness on cyber risks. And this was achieved through the deployment of the CyberMar Cyber Range, an innovative environment providing many capabilities, and also by creating and using training modules through an integrated learning management system, and by validating in 3 demonstrations using real-life conditions the platform developed. The second objective was to assess cyber risk for operational technologies, but without excluding information technologies as well. And for that objective, a cyber risk assessment framework, specifically for the maritime domain, was deployed and integrated into our solution. The third objective was to quantify the economic impact of cyber attacks across different industries, but with a focus on the port disruption. And for that, we have deployed econometric models to quantify the economic risk in terms of economic losses, monetary losses for products and countries associated. And also this model, these results of this work were also integrated into the CyberMar platform. The fourth objective was to promote cyber insurance market maturity in the maritime logistics sector, but in a way that this could be adapted also to other sectors as well. For this objective, we have developed some guidelines and recommendations based on the findings from the pilots and the outcomes we have from the simulations. This is also an ongoing work that will take into consideration today's pilot. And these recommendations will be shared with the maritime domain and relevant associations. And the last objective, the final objective, was to establish and extend the collaboration and the engagement of CERT and C-CERT network, competent authorities, and relevant actors. And for this, specific for maritime domain, a MISP community was created. And also, we have the engagement of certain people in our pilot activities, in all project activities, but also in pilots. So having said that, we can say that the main concept and methodology in CyberMar takes advantage of the cyber edge environment and adopts a 3-tiered approach. In the first tier, we have people, and for people, what we do is continuous training, providing continuous training through their involvement in our pilots, through training sessions provided from our solution, and through their familiarization with the CyberMar platform. In the second tier, we have procedures, actually trying to measure in procedures in order to uncover areas for improvement or any deficiencies in the procedures that are currently being followed in the maritime sector. And in the last tier, we have technologies for which we take advantage of the capabilities of the platform in order to identify complex vulnerabilities in the systems used in the domain's operation. And all this work was intending to be validated and actually evaluated through the pilot scenarios that we have defined from the beginning. The first one was related to energy sources in the port of Valencia, where the platform was applied to simulate the electrical grid of the port, and also included protocols for protecting the grid and crisis management following a cyber attack. The second pilot was about vessel navigation and automation systems, where we simulated a complex ship bridge cyber attack, including attack to control systems, and also used our solution to calculate the impact on the port operations and also wider econometric impacts from this attack. And the third pilot is the one that we are also implementing today during this event. It's related to a SCAD attack in the port container terminal of Piraeus Port, and the platform will simulate such a combined attack, what we will have the chance to see later, but also take into consideration, as Lefteris said earlier, the consequences of the attack to the railway operator network. I will also discuss a bit further in this presentation about the pilots we have implemented and the results we had from them. I want to now have some words about the components of our solution that were developed and integrated. The main component in our solution is the cyber range that provides capabilities to realistically simulate cyber systems for cyber combat training or system development, testing, and benchmarking. It provides graphical interface for building and interacting with such simulated network topologies, but also hybrid connections allow to connect these simulations to real-world equipment or other ranges through VPN, as it is in our case where we have different cyber ranges interconnected. The ship simulator is a platform that also provides the capability to simulate a complete ship bridge, also interconnected with our cyber, with the other cyber ranges, and it was used and validated during the second pilot mainly, allowing us to capture the traffic flow between different components that could be used for offline analysis. The intrusion detection system provides signature-based detection and network monitoring, but suitable for the scenarios, the maritime scenarios we used in our project. The system analyzes the network traffic in the scenario under investigation and provides alerts when an attack or other suspicious behavior is detected. We have security information and an advanced security information and event management system, the XLCM, that provides real-time collection and analysis of events from different sensors in the network, and generates also high-level alarms and reports. And the live anomaly detection system, which is based on machine learning algorithms and analyzes the network traffic in order to identify anomalous behaviors in communication between devices. These monitoring tools, the IDS or the XLCM and the LADS, are coupled with two situational awareness modules that provide visualization either from the current situation in the network and the events that are being monitored and captured, but also provide views, the high-level situation awareness module of the current risk level in the target environment. We have also the MACRA framework, the Maritime Cyber Risk Assessment Framework, that measures the level of cyber risk exposure of the systems under consideration, and provide as a result a quantification of the expected effect of or the impact of the cyber attack on maritime operations, as for example, as a disruption of the port operations, business disruption, downtime, you can say. And also this is coupled with the econometric model deployed that outputs the losses, the economic losses for different nodes in the value chain, in the maritime value chain, as a function of the business disruption days calculated for the selected scenario, and the daily revenue for the product group or country of interest. The prediction engine receives input from the network monitoring tools, receives actually up to the moment sequence of the events of an ongoing attack, and the state of the network. Based on this and the already modeled behavior of attack, modeled knowledge of such behavior, it provides a probabilistic prediction of future steps of that ongoing attack or a future state of the network. These predictions are fused with information from MACRA framework and from the econometric model in order to help defenders prioritize their responses based, we can say, on the impact, on the economic impact that each next event may have. We have also the CERT tool, the MISP, actually MISP community, the maritime MISP community, which actually related to the connection with and cooperation with CERT teams. It has also been used, this community, to improve the cybersecurity early warning in our scenarios by providing additional IOCs and maritime consequences coupled with the IDS mainly system used in our platform. And finally, the learning management system that has been integrated also into our into the cyber range, aiming to improve the performance and cyber skills of port personnel and relevant stakeholders, allowing to create and manage and distribute courses, but also to monitor the impact of the training programs on the business operations. Here you can see, or at least I hope you can see, a generic architecture of our solution. I'm not going to stay on this, just to mention that you can see the main component, which is the cyber range provided by Diateam, also connected with a cyber range from our partners VTT, and also connected at the right side, as you see, with the ship simulator and range from for the University of Plymouth. Inside the cyber range, so all the components are deployed as virtual machines, mainly, and orchestrated by the orchestrator, the green boxes you can see below, that communicates and with through APIs with these components. Now, coming back to the pilots, as I said, the first pilot that were implemented exactly 2 years ago And you can see the recording is available on YouTube, so you will have the chance to visit our channel and see the whole recording of the event. It was about testing and validating our first version of the solution for a cyber attack scenario in the port of Valencia by simulating a remote attack on the IT and OT infrastructure and energy grid by cutting off the power supply to the port. But what we also simulated was also a ransomware attack triggered by the command and control server that cryptologged all workstations within the infrastructure. The main conclusions from the first pilot was to stress the importance of cybersecurity or the importance of testing all kinds of vulnerabilities in the systems of an organization, and that the training is important for personnel to mitigate such incidents. We also demonstrated how severe incident could need from hours to days to recover, based also on the preparedness of the personnel, and highlighted the added value of the cyber range environment to simulate a real network and provide exercises for cyber security training based on a cyber attack scenario. The second pilot, implemented earlier this year, also the recording is available, was the vessel pilot, where we demonstrated how more elements that were integrated into our solution could allow the platform to model a complex sea bridge cyber attack and also its impacts. It was a simulation of attack that allowed the attacker to alter the course of a large vessel and thus causing a blockage to the entrance of the port. The attack was had implemented in stages. The first one was about downloading and propagating the attack within the IT infrastructure. Then the second stage was about installing and initiating the attack on the vessel control system. And the final stage was the actual realization of the attack, the consequences of the attack, and the response of the crew, of the vessel crew, to that. The conclusion from this pilot was about the consequences to a port terminal when a cyber attack targets a vessel visiting the port. We also quantified the economic impact of cyber attacks with a focus on the disruption on port operations, and illustrate the importance of having a robust cybersecurity practices on board that would allow to safely and securely continue operations on both port and sea. We also validated the added value of the CyberMar platform as more components were integrated. And the third pilot that will be realized today is about testing and validating the final version of our platform in the scope of a combined SCAD attack scenario on the port's train gauge network and grid here in the port of Piraeus. We are going to simulate a remote access attack on the port's IT and OT infrastructure, compromising the level crossing barriers at the train yard and thus leading eventually to a collision between incoming train and tracks, but also wiping out the whole grid's IT and OT infrastructure and cutting off the port's power supply, causing a huge impact on operations. Last but not least, there's an important training program in our project that our partner from World Maritime University will elaborate later on. This training program followed a hybrid approach, both physical and virtual. The main points are that we have, as I said, implemented the learning management platform as part of the cyber range. We formulated specific training packages for maritime sector with a focus on hands-on and practical training. We have already successfully held entry, intermediate, and advanced level trainings. But also further trainings through the platform will be are in the process of being organized and will be delivered by the next month, including a major capture the flag competition. So if I could summarize all we have said so far concerning what was being performed in the project, the main achievements is that, first of all, we developed an innovative platform of interconnected cyber ranges that provide capabilities of network monitoring, visualization, data fusion, and prediction in order to increase situational awareness, support decision-making, and offer specialized cybersecurity training. We have interconnected a ship simulator platform for simulating a complete ship bridge and validate this into our second pilot. We have integrated network monitoring tools for intrusion and anomaly detection and alerting, created and connected a maritime MISP community for increased threat intelligence and also facilitate the communication with CERT and CSERT networks. We introduced and validated the maritime cyber risk assessment framework for quantifying and understanding cyber risk in the maritime domain, and developed an econometric model to quantify in terms of monetary losses the impact of cyber attacks across different products, groups, and industries. We used all these network monitoring tools and the econometric model and macro results to provide enriched predictions of future steps of an attack in order to support decision making. Utilized situation awareness tools to visualize all this information and predictions and cybersecurity risk level on the attacked infrastructure. We have demonstrated and validated in real life conditions the CyberMar platform in 3, including today's 1 pilot cases. As I said previously, we deployed the learning management system. We have already delivered 9 training sessions with more than 350 trainees. We have proceeded with important liaison activities with other similar EU-funded projects and maritime association, produced guidelines and recommendations to be shared with the community, and also finally developed a joint exploitation and go-to-market strategy for our offerings. The target audience now for our solution that has been identified includes decision maker, public authorities and international organizations, academia, of course, and of course, port authorities, operators, and associations, freight transport and logistic actors, CERT and CSERT networks, definitely, insurance, shipping, and cybersecurity companies, and European international organizations and networks for cybersecurity. And for this audience, we have identified some benefits of using our solution. We believe that by adopting a platform like the one from CyberMar can lead to multiple benefits for such an organization at multiple level of operation and for different categories of members. For employees, they can definitely experience real world threats in a really safe environment, and they can learn how to recognize threats and develop and expand their cybersecurity skills. For a security operator, such a platform can provide the ability to transfer information directly from testing environment into cyber agents for immediate use into cybersecurity solutions. Also, they can measure knowledge and capabilities of internal and external cybersecurity teams and raise awareness, technical awareness, but also proceed with penetration testing on existing systems. For the management of an organization, definitely they can keep the whole organization level of cybersecurity education high and train their employees, but they can also evaluate cyber risk investments they can make based on the economic impact and also take cost-effective decisions. And finally, for R&D departments, they can design and build prototypes or use the platform for as a test bed for new technologies or experimental environments and test them against real threats, real cyber attacks, and also to design, develop, and test new tools and methods for cybersecurity. Thank you all for your attention. I hope it was not too much of information, but in any case, we think we can have a break now for us to have a coffee and for you watching the event as well. And we'll be back in 15 minutes. Thank you. So we're back and from the break, and it's now time for the main part of this event, which is the Piraeus Pilot implementation. We'll go through some introductions from both for the pilot scenario and for the main components of our platform that will play a role in the scenario. So the pilot today is about, as I said before, an attack to the port of Piraeus container terminal. As mentioned from previous speakers, the port of Piraeus is the first port in the Mediterranean and the fourth port in Europe in terms of container throughput. It's one of the fastest growing ports worldwide during at least the last decade, handling a wide variety of cargo. So this means it's of almost importance to EU trade and the European economy in total. So it is extremely important to be certain that there is a business continuity and that there is no incidents that disrupt the operation of the port, because that would affect also the European economy in total. So the pilot today is about attacking the port of Piraeus, the port container, and the platform will simulate such a combined attack targeting the system controlling at the beginning, at least, starting the attack. We are an attack targeting the system controlling the level crossing barriers around the train yard of the port terminal. And this attack will be followed by the main attack to the port's network, wiping out the entire IT and OT infrastructure and also causing a cutoff to the terminal's power supply. The attack is structured in two phases. The first phase includes a malware execution aiming to steal some security employees' credential and sensitive information from his computer, information regarding port and railway operation, but also, as I said, important credential for entering the network, the company's network. And the second phase includes the initiation of this combined attack to the terminal's IT and OT infrastructure. So the setup of the scenario, let's say we have an APT group targeting the the port authority, and with the support or by utilizing also local criminals. The story is about executing through an evil USB key, a malware, to gain access to this employee's computer. Through this access, sensitive information, including documents regarding port and trains or train timetables, information about clients, but also SCADA system documentation and team viewers and LAN connection credentials are stolen. This way, the attackers profit the access from an existing backdoor, and through that gain access to the SCADA system that controls the level crossing barriers at the port's train yard. Through that access, there will be a reprogramming of the PLCs in order for the barriers to misfunction, and thus causing a disruption, but eventually a collision between incoming trains and tracks. We assume that the incident response process that could be initiated in that case of an accident won't detect the stolen credential, and so the access to the attacked computer will be renewed, allowing thus lateral movement to other machines in the network using TeamViewer and accessing also the smart grid's SCADA system. Through this movement into the network, a malicious code will be dropped, and thus the main attack will launch that will result in wiping out the IT and OT infrastructure, and as I said, causing a cutting off to the power supply of the port, and having as an impact the major disruption in port's operation. This is in short the scenario, but it will be also further analyzed and detailed from our colleagues in the following minutes. The objectives now for the pilot is to assess cyber risk for the port's IT and OT infrastructure, and also to highlight the consequences and the economic impact of such attack to the operation of the port terminal. We hope that we will, through that scenario, we will increase stakeholders, port personnel's cybersecurity awareness, and in order to be prepared to mitigate and resource systems in case of an attack. But what is most important, we want to also underline the necessity of keeping offline backups and also spare computers for quick restoring operations. As we can see in the scenario that will be implemented, this could be a key to minimize the disruption of the port operations. And of course, we want through this simulation to test and also demonstrate to all of you the capabilities of the CyberMar platform and its components. We have also created a feedback survey for this event. We would appreciate if you could provide your views of what we are going to see of the pilot, the story, the platform, and the scenario that will be presented in the online questionnaire that you can see here, but it will also circulated through the chat, to all of you. But in any case, it would be nice if we cover your feedback now. As you can see, it will only take less than 5 minutes. But in any case, I think that the link will be also circulated through mail to all participants. That's it for me for now. So I give the floor to my colleague Nicholas from DIA team to continue with the pilot demonstration presentations.
So thank you on behalf of the team. We thank all the organizations, especially ICCS and PCT, for welcoming us for this first pilot. And we also thank all the technical partners, ICCS, VTT, Atos, and Naval Group. So first, in terms of traffic light policy, this presentation and demonstration refers to TLP clear. That means, in a nutshell, disclosure is not limited. There is a few things to consider. So disclaimer, while the scenario, techniques, tactics, and procedures were designed to and implemented to be realistic, we do not mean that the current IT and OT infrastructure of Piraeus Port is vulnerable. Moreover, and on purpose, we will not reveal details about the weaponization of the attack. The advanced persistent threat we are simulating is inspired by different methods used by different state-sponsored groups. As in real conditions, capabilities may vary in terms of lateral movement and removal of traces. So, short presentation about DIATIM. DIATIM was founded in 2002 on the needs of the French Ministry of Defense. Back in those days, the objective was to simulate, emulate IT infrastructure, and it was on the needs of the French Ministry of Defense. So all the work you will see is originally based on the research of our chairman and CTO, Guillaume Prigent. So we are a research and development company specializing in computer security. We provide cybersecurity training and testing labs, and we are developing innovative cyber range solution. So our cyber range, which is the main module of brick of the cyber range, is for multiple uses. As you can see, for cyber training solutions, cyber awareness, cyber training, and blue team versus red team exercises. And on the other hand, we have a cyber lab solution that enables you to deploy, test, benchmark, and analyze products. You can also prototype and design and pen test some solutions. Obviously, it's really useful for patch management and security assessments. So I guess this is Jonathan, the floor is yours.
Thank you, Nicholas. Right. I will share my screen and continue. Okay. Let me catch up. So, as you've already seen in previous slides by colleagues from ICCS, we have the architecture of the CyberMar cyber range with many different components, and a certain number of these are hosted within DIATIM's cyber range platform. In particular, all of these central box represents DIATIM's cyber range platform, within which we've deployed both our own tools and improvements to those tools, including the orchestrator, in order to manage the range. And within the simulation of the simulation possibilities of the range, we deploy both the target topologies for the networks to be put under tests, and also further tools by our colleagues, such as the IDS tools, the CM, the LADS, and the prediction engine, for example. And today we will also be interacting with the situational awareness and IDS tools by VTT, which are deployed also in their own range and connected to our range via VPN. Just a quick view of the platform we're using. The DIAteam's cyber range platforms are composed of dedicated servers in clusters, and they can be set up in mobile racks, as we have here. And this is only a small one with 3 nodes, but it's set up for the CyberMar cyber range exclusively. And we have also on top in this picture one of the physical pieces of hardware, a programmable logic controller, which is being used for the scenario. Although in this scenario, we actually have 2 physical devices connected to the cyber range via hybrid ports. So just to recap, the cyber range in the center allows us to run the simulations, and it can be connected via hybrid connections to the real world in order to add realism and industrial equipment which cannot be necessarily virtualized in the system itself. And on the other hand, we can still virtualize many, or most, if not all, of the IT systems, which allows us to have the best of both worlds. That is, have the maximum realism while still keeping the cost as low as possible for these simulations. As I mentioned, the core of the range revolves around DIAteam's cyber range platform, which is a multiple user scalable system. So we are running currently on 3 servers, but we can have many more. We also have a full graphical interface to build and interact with the network topologies. And as I said, we can connect the simulations to real-world equipment via physical Ethernet ports, or to other ranges or remote equipment via VPN, for example. We also have full APIs to build and control the simulations and add interactivity to the simulations themselves. On the right, we can see the main graphical interface, which I'll show to you further on, also in real life when we are running the scenario. As I mentioned earlier, we have the VPN manager, which is part of the, integrated with the orchestrator, and allows us to set up VPN connections on the fly or manually in order to connect different equipment and different ranges. And for this scenario, the VTT's IDS tools are connected with a multitude of VPN connections into the simulation. So we have for the simulations, mostly level 2 VPNs. That is, the VPNs behave simply as wires, and all of the network configuration is part of the simulation itself. So the VPN behaves simply as a support for the rest of the simulation, and the level 3 is part of the simulation itself. We also have level 3 simulations in order to connect the administrative interfaces. As well as managing the simulation itself via VPN, we can also actually use these VPNs to connect individual users into the simulation, which is one of the other utilizations of the orchestrator, which we won't be demonstrating today, which is to provide hands-on training in labs in the platform. And so one of the ways that users can interact with these labs is directly with remote desktop connections to the machines which are in the simulation. But also they can connect to the simulation themselves directly via VPN, depending on the exercise that we need to that we wish to run. So quick view of the targeted topology. Today I'll move on to the actual graphical tool for this to show you more. So we can see here the main topology that we have for the scenario, which is a representation of the IT and OT network similar to that of the port of Piraeus, although it's not a copy of that of the port of Piraeus. So we have quite a few segments in the network. Starting at the top, we have the internet connection to the outside world. Although, of course, in this case, it's a simulated internet, which we'll see a little later on. We have the core firewall for the network, and a secondary firewall for the SCADA network. That is the OT side. We have the central servers for the network, including the domain controller Active Directory. We have the DMZ zone, including the VPN server for remote workers, which we'll discuss later on. We have the staff machines for the people working in the port. And on the OT side, we have several supervision machines to supervise the SCADA equipment in the port, and a pre-programming machine which is used to interface with the machines, with the PLCs in order to manage their program. These PLCs, of course, are also shown here. We have here one physical PLC and other virtual PLCs, which are used for the gates controls, especially the physical PLC, which is here. So this is a connection to the physical PLC, which is connected to the range itself. And finally, we also have the smart grid side, which is based on that we developed for the first pilot for the port of Valencia. And so we have a physical PLC, which is representing the high voltage to medium voltage substation. And so running yet again on a physical PLC connected via hybrid ports to the network. And we have various virtual PLCs, which are also connected. On top of that, we have the monitoring systems, which are connected to the network. You can see various red wires across the topology, which are connected as mirror ports to the most important switches in the network. So one in each of the network segments, in the server segment, the client machines segment, the DMZ, and also the OT network. We also have an SSL inspection machine, which allows the system to decrypt HTTPS communications from the machines in the client's LAN in order to inspect also this data in the monitoring machines. So these monitoring machines are represented here, but are actually located in a different topology, which is connected to this one. And so I'll open this one now. So we have the monitoring topology in which we've deployed the tools which we discussed earlier, namely the Excelsiam for Matos, the LADS machines also for Matos, and the prediction engine and econometric model graphical interface. And finally, we have a placeholder for the IDS by VTT, which is, as we discussed earlier, deployed in VTT's range itself. And so we have in this topology actually the VPN connections themselves, which are wired into the mirror ports from the previous topology, as are the LADS machines. So going back to the main topology, we discussed earlier that we also had a simulated internet. And so this simulated internet is another topology, which is here. And so we have the connection back to the simulated Port of Piraeus topology. We have the core internet routing, which allows us to have IPs similar to those in the real world with the various different subnetworks. And in this network, there are several different actors that we are using for the scenario. First, we have a remote worker who belongs to the port of Piraeus, but who is connected remotely for their work. And this will be the initial victim of the attack. And they are connected to the VPN server that we discussed earlier. We also have two machines for the attackers. One is their command and control server, and the other machine is their, let's say, their attack computer from which they will be running the second stage of the attack. I think I've gone through most of the explanations for the networks. We have some more machines up here which allow us to implement some of the systems on the internet, including DNS servers. Back to these slides, as we discussed earlier, you've already seen this this picture, of course. So the topologies that you've seen are hosted on the platform itself, and the physical machines are housed in flight cases similar to these, and are connected directly physically to the range. And of course, VTT's machines are connected via the VPNs. I must have skipped one slide. One other thing I just wanted to discuss rapidly is the orchestrator and action manager that we have. So the action manager is a system which allows us to run programs or commands within any of the machines within the topologies which are deployed in our range in order to either simulate attacks or defenders, and also perform diagnostics and show what state the system is in. And you will see this in action later on as the attack advances. We will be using it in order to show the status of the machines directly on the topology view. We also have the orchestrator, which is most useful for exercises rather than for demonstrations. But we also have it for setup for this scenario, and it allows us, for example, to run some of the install steps to start up the topology. For example, just to make sure, I will reinstall now the host-based detection tools on the machines in the range, which are supposed to have them for the scenario. So we can this uses, of course, the Action Manager, and we can go. We can click through to the Action Manager and see the results of the installment. So we have some messages. So that install has completed fine. Okay, moving on. We can now move on to the different modules. One module we haven't seen in the topology so far is the MISP machine, as was discussed earlier by colleagues from my CCS. And so the MISP machine is also deployed. So there are several machines. Let's say there's a MISP machine, which is at another group's premises, and the CyberMar instance of MISP is deployed in our range also. In another topology with some special wiring in order to make it accessible on the internet. And so the MISP machine is deployed in the range, connected to the internet on one side, and on the other side is connected through the different topologies in order to be able to discuss with the IDS tools from VTT. So I believe Aymeric may be with you and has a presentation to show from a colleague of his.
Yes, Jonathan, thank you. We have a pre-recorded video actually about MISP and some basic concepts and the way it was being used for this pilot. Fortunately, our colleagues could not join us today, so we have the video that I'm going to share with you.
Hi everyone, I'm Arthur Loiseau from Naval Groups, and I'm going to present the MISP of CyberMar. So first, what is a MISP? MISP stands for Malware Informative Sharing Platform. So these platforms allows people to share IOC. IOCs are just information, are just indicators of compromise. So, and it could be of different types: IP address, hashes, for example, everything you want, and it allows people to detect an attack on the system. MISP could be very useful for CyberMar, especially for the simulations. It allows to find real file name, real hashes who came from real attacks, and it could also allows the maritime world to share information, IOCs of maritime cyber attacks. So this is the interface of the MISP. So there are events who are created by people. So for example, we could take the Pilot 2 events, and you could put tag, descriptions, everything you want. And the principle is you could add attributes, so IOCs. For example, this is an IP, a hash, and you could centralize everything in an event. So you could have many events, and those events could be shared with another MISP, another organization, other communities. So and it's very well built because it's very simple to add attributes to share. So we are going to see how to do that. So that's all for the basic presentation. Okay, so now I'm going to present you how to connect to the CyberMar MISP from another MISP. So here is a local MISP on my machine, and I'm going to connect to the CyberMar MISP. So I'm adding a new server with the URL of the MISP of CyberMar. I'm going to add a new organization, so MISP cybermar.org, for example. I need to have an authentication key. So here is the key, for example. I need to enable settings. And like that, up, submit. So now I have added the MISP of cybermar. I could run connection test, so it works. I'm connected to the cybermar MISP. So now what we can do when we are connected to the MISP, we could do many actions. We could explore all the events. We could view them, view the attributes of the event. But we could also pull all the events of the MISP. So this is this action. We just have to wait. We refresh and we have all the events of the MISP in local. So like this, we could view it, see the attributes, and we are going to see that we could add our own attributes to the event, publish them, and push them on the cybermar MISP. Okay, so to push new attributes, we could go into an event that we pull before. So for example, pilot 3. So we have the attributes, and we could add some more attributes. So for example, network activity, snort, to add a snort rule. Don't forget to check for intrusion detection system. We could find a rule, so for example WinRM login, copy paste, submit. We have the new attributes. We could put the command, for example WinRM login. We could add more attributes. For example, VPN, a VPN rule. Put a command. Don't forget to check EDS. And now we just have to publish, publish the event, to push the event into the cybermar MISP. So we could check that. Explore, pilot 3, view, and as you can see, there are two new attributes, two snort rule, WinRM login, and VPN. As you can see, it's very easy to add new attributes and to push into the remote MISP, the cybermar MISP. That's all for me. I hope I was clear on my explanations, and thanks for listening.
As I was saying, thank you for showing the video, and now we can move on to the IDS host-based detection and situation awareness tools presented by VTT. If you are ready.
Thank you, Jonathan. I believe we are. Okay, so can you see the presentation slides? Okay, now?
Yes.
Good. Okay, so hi, my name is Jarkko Kuusijärvi. I'm from the Technical Research Center of Finland, and I will be presenting our modules on behalf of our development team. So, first of all, an overview of the modules we have been developing. So, in the CyberMar project, the intrusion detection system and situational awareness modules are based on the Security Onion, which is an open source Linux distribution for intrusion detection and security monitoring and security visualization. Now, this has been extended with some CyberMar specific features, and all of these modules then represent the target organization IP administrators toolset for monitoring their network. And the intrusion detection and situational awareness modules are running at VDD CyberRange, as Jonathan already told, and they and our whole CyberRange is integrated with Diateam's CyberRange or the CyberMar CyberRange platform with VPN connections, and CyberRange and the modules have specific APIs that allow the orchestrator to control the CyberRanges as a whole. For the IDS module, it consists of several tools. So first of all, we have a traditional signature-based intrusion detection tool, Suricata. Then we have a network traffic monitoring tool, Seek. And then we have host-based intrusion detection system, which is Watsu. And in addition, we've also configured an SSL inspection proxy that allows decrypting and monitoring outgoing encrypted traffic on the scenario. So, for the situational awareness modules, we have the expert situational awareness module, which is mainly consistent of the tools available in the Security Onion platform that we've created some new dashboards for it. And the management of the alerts and events is handled by the Squad tool. And then Kibana is used to display all the graphics and the dashboards. And then we, as I said, we have some custom dashboards created, for example, to visualize the prediction engine outputs, which will be explained later. And then for the high-level situational awareness module, we have a tool developed by VDT called Metrics Visualization System, which is now used in this project to visualize the cybersecurity risk level of the scenario in a high level. So it presents a security metrics model, and this is a filtered high-level view of the selected system. So it takes inputs from the IDS tools, and for example, the prediction engine outputs can be incorporated there, and we can visualize a high-level view that does not have too many disturbing alerts or events visible. I will show you that in a brief. Now the IT network side. Sorry. The intrusion detection system in the IT part of the scenario is consisting of fairly standard IDS setting or tools for any organization. So for this scenario, we have 3 network probes for capturing and inspecting the network traffic. And these probes are installed into the routers between different network segments, which Jonathan already showed in the CyberRange platform. And we have a SSL inspection proxy to decrypt and inspect all the outgoing HTTPS traffic, which allows us to inspect the web traffic. And this is nowadays commonly encrypted, so for this part, we will, or the organization has decided to install this proxy. And also in this scenario, we have installed some host-based detection agents on some of the workers' machine. So it is important to have host-based detection in addition to the network-based detection, since not all malicious activity can be detected on the network footprint, and some actions can only happen locally on the computers, and or the traffic, network traffic could also be encrypted. So the host-based detection agents increase the visibility on what is happening on the actual systems and what the attacker has been possibly doing. Now the IDS system has several detection rules installed. So we just saw the presentation of the MISP. So some of these rules are shared between organizations using the MISP platform, and they describe attack that some other organizations have encountered before. So sharing this sort of information is important, as attackers often use the same methods and tools to target different organizations in the same context. And in this case, shared information include details of the known command and control server. As well, we have some file hashes and other informations as indicators of compromise for this pilot scenario. And some of the rules are logging normal network activity from the IT network. So, for example, we have remote connections and remote management tools. So it is important to notice and monitor this type of traffic, as the attackers often use the stolen credentials and the tools available in the target systems in order to stay hidden. So to not be detected if they are using the, let's say, normal tools that are available and used by the admins on a normal day-to-day operations. Then moving on to the OT network side. So in the OT network, we have a similar setup for the network-based intrusion detection, with the addition that some of the local administrators have installed some rules that can be monitored and log the most important management functions performed to the PLCs. For example, starting and stopping PLCs and reprogramming them based on the Schneider UMAS protocol used by PLCs installed. So in general, it is difficult to include host-based intrusion detections in the OT network, since the PLCs are seldom able to run any security software, but computers used for development and reprogramming of the PLCs have host-based detection installed here, and a SCADA supervision server. So this was the intrusion detection system and the situational awareness modules described in brief. Next on, we will have our CM presentation, but I would like to quickly show, while I'm presenting, the current situation in the high-level situational awareness tools. So, okay, so are you seeing my other screen now?
Yes.
Okay, so I won't show these more, but these are the situational awareness tools, expert situational awareness tools. And now if we take a look at the high-level situational awareness tools, so I've loaded this Piraeus Pilot project network, and this is the, let's say, filtered high-level situational view of the network. So we are seeing the OT and the office network side. We have some of the servers, and then we have the clients that have the host-based detection and or can be some other ways detected from the network as assets. And if we look at, for example, the remote workers machine, which has host-based detection, we have a specific path for shared threat intel. So enemies related threats can be seen here. So if we will see any of these types of events during the pilot execution, we will see changes in this high-level security metrics tree. And also all the values are then aggregated upwards in the tree. So we will have a traffic light coloring from green, yellow, red for the whole Piraeus container terminal network. But okay, maybe this is enough for the initial presentation of the tools. So I would like to give the floor to the next presenter.
Okay. Okay, so good morning. My name is Jesus Villalobos, with my colleague Alejandro Garcia, both from Atos. We are now presenting other cyber range modules from Atos, the LADS and the XLCM, as part of the monitoring and detection and situational awareness platform. And first, we will start with the LADS that will be presented by my colleague Alejandro. So please go ahead.
Yes. Can you move to the next slide, please? Yeah. Hello, everyone. Well, I will speak about the LADS, a brief description of that. Well, the LADS is a live anomaly detection system. It is an asset that is able to monitor and capture a certain network in real time. The main objective of this tool is to detect anomalies in the monitored network. To do this, the LADS uses a deep learning algorithm called autoencoder. And this algorithm must be trained with normal traffic that doesn't contain any attacks. This allows to the algorithm learn about the behavior of the normal traffic, and then we compare it with the new incoming traffic. With this comparison, we have a numerical value that we use for consider an anomaly or not. If this value is large, we consider that is an anomaly, and otherwise it is normal traffic. There is also a threshold that can be configurable to if we want to be more permissive or more restrictive in those interfaces. As Jonathan shows before, we have used two different instances of the LADS, one for the IT network and the other for the OT network. There is done to isolate the traffic between the two networks, because with this, we try to avoid the sharing traffic from the other network, and that maybe could add some noise to the algorithm and have worsened results. In this pilot, we are using pre-trained model of the two instances. They have been trained with normal traffic. And to conclude, all the detects anomalies by the LADS are sent to the tool XLCM via R6 logs. I will give the floor to Jesus to continue the explanation of the tool XLCM.
Good, thank you, Alejandro. Well, so what's the XLCM? What it does, no? The XLCM is a SIEM, it's a security information and event management system. It basically receives logs from different data sources or sensors, and this information is then normalized into events. For this pilot, we are receiving different logs from different data sources, the IDS, the host-based IDS that is received through the IDS itself, and also from the LADS, all of them with similar names, as you can see. But Then all those logs are received in the correlation engine and are identified from those different sources. And the correlation engine, basically what it does is to use correlation rules that defines different sequences of events. When one sequence of events from different data sources matches the rule, it generates an alarm. It is also possible to correlate alarms itself. So if we are correlating alarms, we can generate, again, alarms, but from a higher level. Though to this process of correlating alarms, we call it cross-correlation. Additionally, the Excel CM offers a graphical interface to present all the alarms or events in different panels and nice charts. This information, that is the output of the Excel CM, the generated alarms, are shared with the platform via RabbitMQ, mainly with the prediction engine. Additionally, the Excel CM also integrates with the orchestrator through an API that allows to stop, start, and clean the services in the Excel CM. This is useful for the exercises. Well, the graphical interface of the Excel CM offers us an executive summary with some charts. Additionally, some tables with all the events that have been received. Here we can see the signature of the events received, the date, of course, the IP and ports, destination and source of the involved log, actually, of event, and an associated risk that is calculated based on the type of event. We have multiple filters, and we have different ways to explore this information. Additionally, and in a similar way, we have another panel for presenting the alarms. Those alarms are like a higher level of security events that are the result of the correlation process, as we commented. Here we can also see the name of the alarm, the IP addresses involved, and ports, and also an associated risk that is calculated based on the type of alarm, basically. So that's it. Thank you.
This presentation concerns the prediction engines developed in the ICCS. The overarching idea of the engine is to systematically model past knowledge on attack behavior patterns, to provide real-time predictions concerning vulnerable parts of the infrastructure during an ongoing cyber attack, and ultimately to facilitate educated decisions based on past knowledge and possible risks and economic impacts during an ongoing cyber attack. So for each simulated attack scenario, the engine receives, processes and fuses information from other modules of the platform, specifically IDS sensors and XLCM output events. All these are coming to us in log files, dynamic log files, which we receive and process real time. After the prediction, the predictions, probabilistic predictions, are fused with the outcome of risk assessment from the risk models and combined with the econometric impact of a possibly successful attack relevant to this event, and provide let's say organized information and on what to expect during an ongoing cyber attack. So the engine essentially perceives as event a triplet of data, which consists of three fields. One concerns the event type, the source subnetwork, and the destination subnetwork. Source subnetwork and destination subnetwork are more or less self-explanatory. It might concern the IT infrastructure, the clients, the servers, or the operational technology infrastructure, or some more specific subnetworks. And the event type is actually the alert of the corresponding IDS event, or the seed name as it called, from the corresponding CM event. Each event is matched to a code word, essentially a string of characters, and this helps us to map the sequence of events, or each sequence of events, into a sequence of strings. And then we used a mathematical approach called a variable length Markov model, implemented by a properly extended suffix tree data structure to make the predictions. This is the overall, let's say, overall architecture of the engine. We receive offline first CM and IDS event sequences. We encode them and train the model. And during real time, we receive the up to the moment events from CM IDS. And based on the models, we make probabilistic predictions of what to expect in terms of future cybersecurity events. The predictions are successively combined with risk and econometric estimations, and are fed to the situational awareness module, where the interested defended party can have access to an organized table containing all this information. Okay,
a few words about the integration. This is Yorgos from ICCS. I was in charge of the integration of the engine that Marcus describes into the CyberMar platform. So here is the overview of the architecture for the third pilot, and the prediction engine is mentioned in the red box. As you can see, it is connected with the modules that Marcos described, the IDS and the XLCM, the monitoring modules, where we receive the alerts and the incidents. All the modules are deployed as virtual machines, and also you can see the underlying virtualized network that connects all the entities. The basic idea for the prediction engine, as was described, is that the alerts and alarms are communicated to the prediction engine via the sensoring modules. Especially with the IDS, we are connected via syslog mechanism, and with the XLCM via RapidMQ. And then the prediction engine processes all this incoming data at a real-time basis and outputs the prediction to the situational awareness module. We have implemented on top of the prediction engine some APIs to connect with the platform. Essentially, these are automated ways to start, stop the engine, clean the historic data, or upload some new and updated configurations.
Okay, this is an exemplary output of what to expect in the situational awareness module. We see a table. Each row corresponds to a predicted event. We give probability of the happening for each event in terms of lower and upper bounds. Plus, you will see in the last, let's say, 5 columns, information concerning the delays that are estimated to be inflicted in the infrastructure, in the port infrastructure, if the predicted event and the predicted attack relevant to this event is successful. The column description essentially provides the description of the event, like we said before. What we use is the destination subnetwork. You will see that we have here OT gates is actually the operational technology concerning the gates of the infrastructure. Operational technology OT means general PLCs or SCADA systems, and servers. These are the most important things in which the infrastructure is very sensitive for. Now, since someone may need some more information concerning the econometric impact of a successful, potentially successful cyber attack, we have built an application for the person to be able to have easy access to this information. My colleague Giorgos will present right now this.
Yes, basically this is the econometric model web service. What this does, we will also showcase this later at the demo, but I will give an overview. So basically for each predicted event, a predicted downtime is produced. But this is on the scenario that we predict. Via this application, we allow the user to experiment, to play around with multiple scenarios that he chooses. So basically, a worst case scenario or let's say best case scenario according to some parameters that he can introduce. As you can see in the figures, the user can basically select the source port, which is basically configured in our case according to pilot 1, 2, or 3, the downtime and the origin country and the product that are related that are of interest. And then according to the market share percentage or the company's revenues that are introduced, we provide the relevant impact in terms of economic loss. So basically, this is an easy to use application, web-based application that allows the user to play around with the results that were presented earlier and tune them and check the respective outcome in terms of the econometric loss.
So that's all. Thank you for your attention.
Back to Jonathan, yes. Jonathan.
Back to Jonathan. Jonathan.
Thank you, Rogers. Thank you, Marcos. So now we'll be going through the pilot and starting by explaining more in detail the kill chain and the scenario. And so for this, Nicolas will be talking, and I can share the slides if you want, Nicolas, or you can share them yourself.
I can do this.
Okay.
Yes. All right. So now we are going to cover the pilot walkthrough, meaning that we will cover kill chain and scenario. So first, definitions. APT stands for Advanced Persistent Threat, which means it's an authorized access to IT/OT system for a long period, usually by a stealth nation state or state-sponsored actor for espionage or planned destruction. As for command and control, aka C2 or CNC, it's a server handling the communication, orders, and results between a remote attacker and a victim. The target device is infected with a malware on the client. The attacker managing a server, usually hosting servers in proxy countries. As for the red team, it's a team of ethical players acting as a cyber criminal nation state enemy or competitor for training or security assessment, or like in a boxing club as a sparring partner. So I want to many thanks to our red team for their guidance within this pilot 3, because we managed to mimic certain techniques and tactics from state sponsor actor. And last but not least, there is a common framework in terms of technique and procedures, which is called MITRE. MITRE attack stands for adversarial tactics, techniques, and common knowledge. It's a framework, a set of data matrices, and assessment tool developed by MITRE Corporation to help organization understand their security readiness and uncover vulnerabilities in their defenses. This is a well-known and recommended reference for obviously certain systems. And we will point through the pilot work through the different steps what is the technique used by the attacker. So this is the first phase of the cyber attack on the Piraeus Pilot event. So phase one, through 5 steps. So first step is reconnaissance, meaning the attacker, the criminal APT group will combine with a local criminal group within in the country of the Piraeus port, in order to spot personnel belonging to the Piraeus port. Then there will be a weaponization by the APT group. So it's it's the main activity before starting the action on the field. It's about how to craft malware in order to avoid detection. So this is the second step, and the first step is delivery. Delivery will be handled by local criminals. So yeah, it's let's say a commercial partnership between APT group and local criminals, or a criminal partnership, to say the least. So delivery will be handled by a local criminal group, and once the malware is executed, there will be a remote shell, and if the remote shell is effective, it will trigger a payment. So once it is effective, local criminal group will gain cryptocurrency, for instance, Bitcoin, but who cares? Once it's done, APT group will profit from backdoor, existing backdoor. So we will try to demonstrate that we can sideload the DLL in thanks to OneDrive design within the Windows machine, recent one. Then APT group will be able to do a recon or discovery of the host and of the local network. And then by stealing credentials, they will be able to do a lateral movement using common remote services like TeamViewer. And still using TeamViewer, they will be able to this is the second time they will craft malware and weapons. By dropping them in the local network, there will be finally 2 actions on objective. The one is, so this is the sixth step. This one will be gate disruption within the port itself, causing potential collision between train way and truckways. And sometime later, for it is a APT group, and we are not dealing with an objective of ransomware or you know, it is only the main objective is to wipe the entire IT and OT infrastructure within the port. So in terms of steps, in detail, I'll try to be quick on this walkthrough. First, reconnaissance. So let's for APT group, it will be a joint work with local criminals to identify targets, meaning IT or OT manager within the port, finding physical address to identify targets, cars, and parking lots. Then weaponization, as I said before, will be a crafting of an ISO file that contains a malicious LNK link which uses scopy to copy hidden files embedded in this very ISO into a OneDrive folder. So in terms of Mitre attack technique, it is called user execution malicious link. And the tactic is execution. So it implies the user interaction. So it's clearly spear phishing. But in addition to this weaponization, of course, the APT group will set up a command and control C2 called Havoc. So it's a matter of hours or days. Then we enter the phase of the action. So the delivery will be done by local criminals leaving one or more evil USB drive lost in a parking lot. This is a real statistic. Rate success for this technique is 50%. On offline IT and OT system, 80% of attacks come from USB devices. So it's a matter of minutes or 2 days. There is a reference, historical reference in concerning this kind of attack. If you remember well, Stuxnet attacker did use this technique. So once delivered, the weapon code is triggered thanks to the user interaction. So the technique is subvert trust control mark of the web bypass, meaning binary and executable file through this USB key will not be spotted by the Windows Defender. It won't trigger the mark of web detection. Unlike if you, for instance, download a binary or executable through your browser within your computer. So exploitation, discovery, and harvesting. Thanks to the OneDrive DLL side loading on target, attackers can benefit from a remote shell and interacting via the command control, which provides a quite good persistence. For obviously, because OneDrive is run as startup by default within Windows system. So this is a technique. There are two techniques covering this step: DLL side loading, boot and logon auto start execution. Then attacker will find that this machine is contains interesting credentials. So using some uploaded PowerShell script, they can harvest credentials, for instance, VPN cred, and through the use of a keylogger, they can log any keyboard strokes. So technique, once again, from a Mitre attack framework, input capture keylogin. Phase 2. This is a depiction of phase 2. APT using TeamViewer, while Security Operations Center, aka SOC, looking for Havoc C2 and lateral movement. Phase 2 will begin by the stealing of credential from OpenVPN client and exfiltrating OpenVPN certificate that enable the attacker to connect via OpenVPN later on. So once again, within the Mitre attack, credentials from password stores, exfiltration over C2 channel. Then attacker will spot some remote service command and control, meaning in this peculiar case, TeamViewer, and then they will be able to abuse TeamViewer service command and control. So once again, technique from a Mitre attack, remote access software, tactic, command and control. That's simple. So minutes to hours it will take. Then in terms of crafted malicious code, once again, through the use of TeamViewer, attackers can access all the SCADA monitoring machine, and they will be able to drop or upload malicious code on the machine, on any machines on the LAN. And we are entering the last steps of the phase 2 of the attack. So first action will be get the disruption. Once gaining access to the SCADA supervision machine, the attackers stop and reflash the PLCs with new firmware. This causes a dysfunctioning of the gate. Fortunately, or it depends on the side you stand, or unfortunately, it requires good timing to maximize damages. At the crossroads of trucks and trains, increasing the risk of collision and disruption of the logistics chain within the port. So this is a tactic within the MITRE attack called firmware corruption, and tactic is impact. As for the last step, which is the most devastating step, the second action is the global IT OT wiping. Once again, using a VPN and TeamViewer access, the attacker will drop a malicious code on the machine within the LAN, execute it, causing the wiping of master boot record and on all the machine connected to the cybermar.com domain, which means including all remote workers connected via VPN, and wiping all the PLCs. So we call this wiper not pre-up. It will be executed on one workstation and autonomously lateralizes to the domain controller and propagates through the network using SMB and WinRM. So this is part of the MITRE attack framework. It is called, as a technique, disk wipe, and it's as well a tactic impact. It's a matter of minutes. So let's play the game live. John, the floor is yours.
Thank you. Just a second. I'll share my screen. Thank you, Nicholas. So we are back in the simulated network, and so as Nicholas explained, the first victim for the attack will be the remote worker, which is connected via VPN to the network. So the VPN server, as I discussed earlier, is over here in the DMZ zone, and of course the user connects via internet. So let's go to the internet topology. So the machine of the remote worker is here. So let's enter this machine. Currently, the machine just started up, so the user is not connected to the VPN. So the first step is to connect them to the VPN in order to have the host space detection tools functional. So you'll notice that the VPN credentials we're using are the user's credentials on the domain. That is because the VPN server itself validates the user's credentials against the Active Directory itself. They're also saved for ease of use by the remote worker. And we'll see that this, of course, is an issue later. But it could also they could also be recovered even if they were not saved, as we'll also see. So first we'll connect. So the user is now connected to the VPN, and we'll activate the host-based detection on this machine in order to be able to follow the attack. So we're using, once again, the Action Manager. Just waiting a few seconds for the host-based detection to finish starting up. Okay, and the initial startup is completed, so we can continue as now. So we are, as mentioned, on the remote workers machine, and they have found a USB stick in the parking lot, and curiosity has got the better of them, and so they are going to connect it to their machine in order to inspect the USB key. So I will be connecting the USB key, the virtual USB key, to the machine, although it will show up as a normal USB key in the Windows. So the USB stick has been connected, and it's auto mounts in Windows, although it doesn't execute anything yet, as we mentioned earlier. There is an ISO file for the user to open. So we shall open this file. And this file contains a link which says confidential cybermar.pdf. So clearly this must be quite interesting. So let's see what this PDF is about. Fortunately, once we click on this link, the payload is activated. So in this case, we've left several telltale signs, including opening the calculator, just to let us know things are working. This is completely optional. The PDF file has actually opened, so the user will actually see the file that they thought they were going to see. But we also have Microsoft OneDrive, which was reopened. This is also for the needs of the exercise. That is, in order to accelerate the connection of the agent to the command and control, we forcibly restart OneDrive in order to cause the connection to set up immediately. In normal case, this would not happen, since we would not have to restart OneDrive immediately. And the connection to the command and control would simply start at the next login of the user. So I will close this window, and we will see on the command and control machine that the machine has connected to the command and control, from where Nicolas will be able to run the inspection commands in order to recover information from this machine. So I'll share the screen while Nicolas does his commands.
Yes, John. Can you hear me?
Yep.
So having a remote shell on the command and control, we can run commands like list DNS, for instance, on the victim's machine. Then you can also run net domain command in order to confirm we are on the target. And obviously, we can also run a command called net logons in order to reveal the username of the machine. I will run a command because within the ISO file, we were able to drop a hidden file called I guess your password. So John, I guess you will see a pop-up, fake Windows security pop-up on the victim side. Yeah.
Indeed, as you can see, the command that was executed by Nicolas has opened a Windows sign-in dialog. This could be launched either manually, as we did here, or could be hooked into the startup of another program in order to increase the likelihood of the victim actually entering their credentials. So in this case, I will fall for the attack.
So, yeah.
Yes, apparently I mistyped. Yes, here we go. Okay.
So yeah,
credentials would have been returned back.
So credentials were stolen. So I take the floor, John.
Yeah, carry on.
So then, having stolen the credential with a fake security windows, we can proceed to a discovery of the machine within which we can access browsing the system to the OpenVPN certificate. So thanks to this tool, we can also download the OpenVPN certificate, which is a yes, the standard path within Windows machine for OpenVPN. So I will download the OpenVPN certificate. So now the OpenVPN certificate has been exfiltrated. So what else? We can also yes. Upload a PowerShell script on the victim's machines for recovering OpenVPN credential in the Windows registry. So I'm going to upload the PowerShell script and then execute the script like this. As you can see, the PowerShell script reads the Windows registry and reveals the username and the password.
So as you mentioned,
we also embedded a keylog in the ISO file and the keylogger actually is running. So let's check if we can read the log. So yes, John, it's your turn.
So for the moment, we only have simply a username and password that I entered earlier in the I guess your password tool. In real life, obviously, we would have to wait for the keylogger to capture a significant amount of data in order to hope to have the passwords. However, one of the things that the keylogger will allow us to do is recover, for example, the OpenVPN passwords if they had not been saved in the registry and the script that we just executed had not allowed us to recover them. What it will allow us to recover this time is the credentials for TeamViewer, which the remote user uses in their daily work in order to interact with the other machines in the domains network. So from my machine, I'll be using TeamViewer in LAN only mode, so completely inside the target systems network. And so I have, for example, the IP of one of my machines already entered. I'll connect to this machine. Of course, I will need to enter the password. And so this password, of course, will be captured by the keylogger. And from here, I have access, of course, to the machine as if I was directly connected to it. This is the advantage of TeamViewer, of course. And continuing my my daily work, I can also connect to the other machines which I will be using. And so I can connect to the supervision machines for the gate control, for example. Okay, so we have a direct visualization of the gate supervision, which I'll explain a little bit in more detail just before the next step. And I'll also connect to a couple of other machines, which will be of interest. So we have the supervision machine for the power grid. Okay, and well, TeamViewer interferes a little bit with the communications with the with the substation, but that's nothing too important. It's simply a timeout issue. There's slightly too restrictive on the time it takes for the PLC to respond. And finally, I'm going to connect to my desktop machine in the office. Okay. So, of course, this functions as normal. Although it does not use internet at all, it simply connects via the VPN to which the user is connected. So having connected to all these machines, the attacker will also be able to recover the list of machines which I've connected to from the history of TeamViewer. And I think, Nicolas, you've got that ready.
Yes. As you may see, we can see the keylogger and all the keystrokes previously, and also we can for instance we can create an archive of the TeamViewer configuration on the victim's computer with by creating a zip file called teamtvc.zip, and of course we can exfiltrate this zip using a command download, as it's really simple, as you may see. So download all the configuration of the TeamViewer from the victim's computer. Of course, we can also proceed to the removal of some tracks, like removing the PowerShell script. And exfiltrating also this is really important as an attacker, exfiltrating the log of the keylogger. And of course, we can kill the keylogger running, which is called pgp.exe. So we can list the process, and as we can see, there is a ROG PGP binary running, so we can kill this process. Then remove the process. Obviously, it will not help the security emergency response team to investigate.
Of course, it's always best to cover our tracks. However,
so that's it from my side. John, you can.
Yeah.
Proceed.
Can everyone still hear me? Can you hear me?
Yes, Jonathan.
Okay, great. Okay, so now the attacker has the information they need in order to continue their attack. That is, they have recovered the OpenVPN configuration file containing the certificates, and they also have the user's username and password that allows them to use the VPN connection, and also they have interesting files that they've recovered from the user's machine, and in particular the connections to the other machines in the network via TeamViewer, and the password for TeamViewer. So now the user does not need the command and control agent anymore. They can directly connect to the target network from another of their machines. So let's do that now. So we're now on a Windows machine, which is not part of the domain. This is this machine belongs to the attacker, and so we have the VPN credential, well, not credential, configuration and certificate file that we exfiltrated earlier, and we've already imported it into OpenVPN, and so we can connect to the VPN ourselves. So we'll be reusing the same credentials, of course, so the username and password. And we'll connect ourselves to the VPN as if we were the original victim. Let's take a minute or so. In the meantime, I will show you the network in more detail. So as we discussed earlier, we've got several OT networks, well, several parts of the OT network in the system. We have the power grid. So we have a supervision machine for the power grid. So we have various systems. We have first substation transforming the high voltage to medium voltage for supplying power to the port and to the various equipments which are deployed throughout the port, and also for the ships which are cold ironing, for example. And then there are various low voltage transformers throughout the port. So these are running programs on the PLC, on the virtual and physical PLCs. So the substation is running on the physical PLC, and so we have access to the measurements which are made by the PLC, obviously simulated, and we can actually control some aspects of the system. So I could disconnect everyone if I wanted to, and so I'll break open and so on. I won't disconnect everyone right now, and so we have the power curves for the system. So this, of course, will be shut down completely in the last stage of the attack. And so we, as mentioned earlier, we have the physical PLC, which is connected via this entity here, and we have the virtual PLCs running the low voltage transformer programs over here. And on the other hand, we have the PLCs for the gate control, mostly running on the physical PLC, which is connected with this entity. And we have the supervision for the gates running on this entity here. So this one was inspired by the supervision of the actual gates in the port of Piraeus, for which we have I have some screenshots to explain the situation more clearly. So as some of you may know, in the port of Piraeus, there's obviously not a lot of room, and so the railroad and the trucks must cross at the entrance to the terminal. And so we have in red the trajectory of the incoming trains, and in green the trajectory of the incoming trucks for the main entrance. If we zoom in, we can see we have several gates that are controlling the entrance of the trucks to the port, and we also have the railway across the middle. And so the trucks must cross the railway in order to enter the port. There are also, of course, various sensors on the railroad in order to know that a train is incoming, also based on the schedule of the trains. So the supervision is also using these. In the supervision that we've built for the scenario, the PLC is actually simulating 4 lanes of traffic with incoming vehicles at random intervals, of course. It's a simulation, and managing the gates in order to let them through. However, of course, it does not let the trucks through if there is a train coming. And so this is handled by the program, so I can simulate that the train is coming. And so once a train is arriving, even if a vehicle arrives waiting at the gate, of course, does not open until the train is cleared. As you can see, there are vehicles waiting in all of the lanes, and they have been cleared for entrance. However, since there is a train actually crossing the entrance, the gates, of course, remain closed until the train has cleared the passage. Just take a few more seconds, of course. Okay, and now that the train has cleared the passage, the gates reopen and allow the trucks to go through, and operations resume as normal, allowing the trucks through once they are allowed to, and so on. Okay, going back to the topology, we saw earlier there was also a development and reprogramming machine in the network, which is named Unity, since that is the name of the program which is used for the PLCs that we are running today. And so this machine is the one that the attacker will be very much interested in. So let's go back to the attacker's machine on the internet. So, of course, since the last few minutes, the attacker has managed to connect to the VPN with the credentials, and so they'll be using TeamViewer to connect to the machine with the with the IPs that they recovered from the victim's machine in the zip file earlier. And so they will, of course, inspect the various machines that they can connect to, but we'll skip straight to the one which interests us today, and we'll connect to it. So, of course, we have access to the machine. From here, we can inspect, of course, the projects in the development environment. And of course, as a normal, completely standard feature of TeamViewer, of course, we can recover files directly from the remote machine. So I know where the files are, so I don't need to search too long. But of course, we can spend more time if we need to. And so we have the gates programs files here, and we can recover them to our machine in order to inspect them at a later date if we want. So I can receive those files. And so now the attacker has the programs for the PLCs locally on their machine, and so they can inspect them and modify them. So we can assume that the attacker has already done so, and so we will actually take the modified program that the attacker has prepared and send it, in this case, to the reprogramming machine. And so I've already opened earlier the correct program. So now I'll actually open the modified program. So we have a modified PLC project. And so I will connect to the PLC. Of course, it tells us the project is different since I've modified the project. Now I'll send the project to the PLC with the modified code. And restart the PLC, of course. All right, so now the PLC is running as before. There is only a little change that's been made. That is, in the normal processing of the gates, there is a slight deviation. That is, once the firmware has been modified, if it detects, once the train is just about to cross the road, it immediately allows the gates to open, whereas they were closed normally before that. So we will see this functioning on the actual supervision. So, well, that's useful. There's actually a train here already. I don't need to force a train in the simulation. So there's a train arriving, and so the gates have all closed, and there are vehicles waiting to cross the level crossing. So as the train arrives, the various sensors at the approach turn on. And so when the train arrives at just before the crossing, so the last sensor, we see all the gates have opened. And so the vehicles are allowed to cross. Of course, they have to rely on some of the drivers not paying attention. And timing is obviously very critical. So in this case, obviously, we've skipped over the fine tuning that would need to be done by the attackers in order to try to ensure maximum probability. Okay, and in the main topology, as I mentioned earlier, we had the action manager, which is running scripts on the machines in order to check the status of the machines and provide some feedback. And so we can see that the physical and virtual PLCs for the gates have been reskinned with a warning icon in order to let us see what's going on. Of course, this relies on us knowing exactly how the malware functions on this side. This is not based on the detections, which we'll see in the other tools. So following this incident, the port obviously has to investigate what's going on, and in our scenario, they do not manage to immediately discover the entire extent of the attack, and so they might, for example, be able to detect the command and control communications and cut them off. However, we still have access via the VPN with the stolen credentials. We could, of course, also have dropped other sleeper programs in order to regain control at a later date. And so the attacker, taking a few days, will continue to inspect the items that they've been able to recover from the initial victim's machine, and also any further inspection of the network, and manage to craft a specific payload in order to wipe the entirety of the domain. So we have obviously all the Windows machines and servers, and the read-only domain controller. We have the PLCs, which have already been reprogrammed once for the gates, but we also have the power grid, which of course is very interesting to shut down as well, and the supervision and development machines themselves, and finally the remote workers, which are connected via VPN. So in order to prepare for this, obviously, after the first attack, the attacker would disconnect from the VPN. So we can do that. And at a later date, obviously the attacker would reconnect, reusing the same credentials as before, or potentially new credentials that they obtained via one of the other channels that they could have installed. So the VPN is now reconnecting. While it connects, I'll just go over quickly the attack method. So the attacker will drop the wiper payload on one of the machines which is connected to the domain. Actually, they will use the remote worker victim's desktop in the network itself, just in case the remote worker is not connected to the VPN at that particular time. And they will execute the payload from this machine. The payload will then lateralize itself to the domain controller, and from the domain controller, it will re-execute itself and propagate to all the machines in the network by enumerating the machines which exist in the Windows domain and connecting to them, transferring the malware itself and re-executing it on each of the machines in the network. So let's do that. So the VPN is connected, so I'll restart the TeamViewer. This time I'll connect to the remote, to the initial victim's desktop machine. Okay, log in. Once again, I can open the file transfer and I will send my specially built wiper. Okay, so the file has been transferred, extract it here. And start executing the payload. I'll switch to the machine itself so we can see slightly bigger. Well, can't see very much. It's copied to the domain controller. And so this machine has been damaged and is now restarting. And during this time, we can see that the program is executed on the domain controller. However, we are out of luck. This time, it has not managed to perform the full wiping of the system. So let's connect to a different machine and rerun the malware. Obviously, we've lost our TeamViewer connection. So let's try it this time from the Unity machine. Of course, it works 90% of the time, but not during live demonstrations. Okay, so once again, we copy the binary. We start the malware, so it copies itself and executes itself on the domain controller, hopefully. Apparently, it does not like me today. So it's quite possible that the lateralization from the SCADA network is not possible, which means that the firewalling has been done properly. In which case, we'll have to try from a different machine. I suggest that we try from the one of the machines which has already been infected. But where it did not actually have time to execute. Okay, so we have the malware executing again on the domain controller. And we can see the malware is executing on all of the machines in the network, including the SCADA machines. And we can see that once it reaches the SCADA machines, it reprograms the PLCs. So it takes a little longer to reconfigure the physical PLCs. But we have the physical PLC for the gates has been reprogrammed, and the physical PLC for the power grid also. We have the all of the client machines, which are now unbootable. So if I try to open any of the client machines, they cannot start anymore. They have been rebooted, but their master boot record has been erased, so they cannot start. We have the same issue for the Windows servers, so the Exchange server for the emails and the backup server. We also have the PLC programming machine, which is being wiped, and the supervision machines are also in the same state. And finally, we have the domain controller, which is also unbootable. It takes a few seconds for the icons to be updated. There we go. And as we mentioned earlier, on the internet, the remote workers, which are connected via VPN, the initial victim, which is the only machine we had connected via VPN, which was part of the domain at least, has also been wiped. Of course, the attacker themselves are connected to the VPN, but are not joined to the Windows domain, and so they were not affected by the propagation from the domain controller. Okay, so the attack itself is complete, and so we can hand over to our colleagues to inspect the results of the detection tools, starting with the IDS tools by VTT, I believe.
Okay, thank you, Jonathan.
Okay.
Can you disable screen sharing so I can share mine?
It's all yours.
Thank you. Can you see my screen?
I can.
Okay, so I am Jukka Julku from VTT also, and I'm now first presenting the IDS tools that Jarkko mentioned in the previous presentation, and then we are going to have a look into the other tools presenting information about the attack and the situational awareness.
Jukka, you might want to enable upscaling of the remote display for the remote viewers to be able to see better. And the view menu, I believe. You have scaled this. Well, yeah, that works even better.
Yeah. Is it readable now?
It's much better, thank you.
Okay, so this is one of the tools in the situation awareness module, and it shows what the signature-based IDS system, so the Surikate tool, has detected about the attacks. I have now put it so that it only shows the time of the attack, but here you can see that there are lots of events here, and most of them are actually describing normal network traffic and are not even related to the attack. So it's kind of common that these kind of tools detect lots of false positive and lots of normal events, and that's supposed to be so. If you then try to spot from this list of events that how the attack went, there are some signs of it. For example, the OpenVPN connection in the beginning of the attack, it was locked because the admins had this kind of local rules for monitoring all the VPN connections. Then one clear sign of the attack was this USB device. It was detected when it was inserted into the system, and the host-based detection actually also detected the malware that was downloaded from that USB device. So we have here event about this malware, and it was detected based on the hash of the file. Apart from that, there are not many events that could be directly said that they are related to the attack or some attack except for these two events that are related to the command and control channel used by the malware. And what's common with these and then the detection of the ISO file is that all of these were actually received from the MISP system. So they were inserted into the system as we saw in the video earlier. And what's important is here that because these rules describe this kind of common IOCs for the attack, and somebody else has now detected those earlier. And because of the information sharing between the organization, that was basically the only thing that in this scenario now made it possible to have this kind of clear signs of the malware, because none of the other events describe anything else but this kind of normal traffic, because the attacker is using tools that are already available in the target system. So that's something to kind of remember, that information sharing is basically the only way to combat this kind of advanced attackers. And then we have lots of events about this normal traffic, as I said. For example, Windows remote management tools, TeamViewer are used. It could be used, for example, by admins to help local users. We have traffic that describes operations related to the PLCs, for example, starting and stopping, then reprogramming them. But that could also be kind of normal activity in the organization. But because the administrator are locking this kind of traffic, it makes possible to also detect attackers that you are using the same tools, and also it makes possible to do incident response before afterwards, because we have this information available. One of the other noteworthy things here is that the ISO file and how it was detected was actually the host-based detection. So all these OSAC events are coming from the host-based detection. So it's not enough to just monitor the network and try to determine what is going on based on the network-based information, because in this attack, for example, kind of the most clearest signs of the attack, they were actually only available on one of the hosts. So the machine of the admin, that was kind of the first entry point into the system. And the file has, or the file, it was only available within that system. So it couldn't have been detected by using the network information. Okay, this was all that I had about the IDS system. And next we will hear from Atos that what their CM system detected, or what kind of information it contains about this attack.
Okay, thank you, Jukka. I'm going to share my screen now. Okay, so this is the main homepage of the XLCM. So here we have an executive summary of the status of the monitored infrastructure. Actually, we have some generic charts telling us how many alarms and events have been generated during the last hours or days. And we can also see which alarms have been more generated, the top 5 also of the events. This is general information. Then we have the events panel and the alarms panel. At the events panel, we have this table can be filtered. We'll see. Where we have the signature of the received event, the timestamp, the IP addresses and ports, okay, and the associated risk that is given when configured the type of event. Here, we can filter, for example, by the data source. So we have the different data sources that we described already. The LEDs, this is Nord or Suricata, and OSEC, the host-based IDS. So we could filter by them if we want to. For example, can filter by OSEC. This is one of the most significant in this attack. And we can see the different events that have been received. Some of them are duplicated, as you can see, but we could also filter by unique events, and we have a similar view, okay, with the unique events that have been detected. Within a timing table here, so we can maybe spot or better understand how the attack has been performed in the time. In that line, we also have the time analysis view, which provides a timetable of the events that have been received in the XLCM. So we maybe better understand the sequence of events that have been received and detected in the network. From here, we can dive into the events details. And when opening the events details, we see, of course, the signature, the name of the event, the IP addresses, ports, the associated risk, and some sensor-specific data. In this case, we are looking at a LEDs event that came from the IT network, as we can see. And the LEDs provides two values. This is the value that actually was used to calculate how anomalous the traffic is. So how different it is from the normal traffic that was used to train the LEDs. And a list of the network statistics, let's say characteristics, okay, that are used in the LEDs to detect how different, how anomalous the traffic is. No? So we have different values here that have been used, how different those statistics values are. Well, those are the events, actually. We also have at the CM panel the alarms, okay? I have it open here. So in the alarms panel, in a similar way, we have the result of the correlation process. So the different correlation rules have detected the different sequences of events and generates those alarms that are then sent, of course, to the prediction engine. Those alarms, here we can see the name of the alarm, the IP and port addresses, and the associated risk. So if we open an alarm, okay, for example, we can see here that we have alarms from the OT network. So we have the LEDs have detected anomalous traffic in the OT network and in the IT network. Also, we have this alarm that says that the PLC has been reprogrammed. How can the XLCM know that? Because it has received all the sequence of events that are required to reprogram the PLC. So it has detected this sequence, so it generates an alert to say that the PLC has been reprogrammed. We talked previously about the cross-correlation process. In that case, we created a correlation rule that correlates alarms from the LEDs and from Snore. So it's able to correlate those two alarms. Why? Because a reprogrammation of a PLC could be something that is present in a normal traffic, but the LEDs have the ability to detect if it is actually anomalous, because maybe it has been reprogrammed in a different way, or there is something that is different. No? So we can spot that this reprogrammation has been unexpected by correlating these two alarms. Okay, when we detect that the uses, ports and sources and destination IP addresses has been used. No? So we are sure that the flow is the same, that the connection is the same. When that happens, we generate this higher level alarm, across alarm, to let the analysts know that this is not something that is expected. Well, that's it for the XLCM. As we commented, all these alarms are then sent to the prediction engine that will be also shown this later. Now I give the floor to VTT for presenting the essay.
Okay, thank you. So I will continue with the situational awareness module presentation. Let me just share my screen quickly. Okay, and now it should be visible. Can somebody confirm?
Yes, it's visible.
Thank you. Okay, so in the early phase, I showed the high-level situational awareness of the Piraeus network. That was all green. Now I have a snapshot at the beginning of the attack here presented, because obviously at the end we would have a lot more red nodes in the graph or the matrix tree. And we've also added some prediction engine predictions in here. I will show them separately. So if we zoom in, we can see that in the remote workers device, we have plenty of yellow and red nodes. So if I zoom in a bit, for example, there's some unusual VPN activity, and the USB disk was attached to the device. And then we can see that from the MISP, so the threat intelligence shared from the MISP, we have one measurement probe alert, which is actually saying that there was a file called North Sea automation.iso that was reported in the MISP as malware. So at this point, this high-level situational awareness would point the analyst to go further into the expert level situational awareness, and they could use these values as a starting point, for example, to see what the situation in the network is now that the other clients are not affected yet. But at that point, the user had already executed the malware, so there was also some HTTP traffic that was monitored with the IDS tools, and that was related to the MISP-related threats. So in this case, we focused on the high-level situational awareness on the MISP threats, but this security metrics tree is usually built from doing a risk analysis of the system, or the individual machines and the whole network, and forming a tree such as this. But the analysts can then filter out some nodes or parts of the tree that are not reasonable to be viewed. So depending on the viewers, we can then filter this view to show the relevant threads or the relevant events, and also move onwards from there. But okay, so we saw that the remote workers machine was detected. Then if we jump into, let's say, the expert level situational awareness, and I have a few filters here as well ready. Obviously, the time was a bit off, so the attack was at some point like this. So the scenario started at around 11 o'clock. So we can see that here we also have the USB detection available with lots of more information. And actually, this was executed after the USB was attached. So clearly, this was the initial point of vector, attack vector. So then I can also show some other relevant attacks from this view. For example, I have the MISP suspicious HTTP content type headers, which were associated with the Havok command and control that was also shown in the high-level situational awareness. And as we saw in the square tool as well, there's quite a lot of these connections. So this is only showing off a small subset depending on the filters that we have applied. Also, if we look at the agent logs here, we can see the last event from our agents. So the hits machines was at 11:48 something, and the agent was disconnected. So obviously, this is a bad sign unless it's a scheduled shutdown of the machine by the employer, but obviously connected to the wiping of the machines. And now the square tool already showed the detailed information of the network intrusion detection probes, but we can also see that in here in the Kibana side. I won't go into details of these connections anymore, but we can see a lot of this Windows remote management traffic going from one host IP to a lot of other IPs. So obviously a bit suspicious, but needs more analysis whether this is actually malicious or not. And we are seeing also this Modbus traffic detected as neither block requests. Then moving on, checking the hits panel from the expert situational awareness, we can see all our agents here. I could, for example, check out the remote workers machine here. If I will first delete this one. And okay, so these are the latest events for the remote machine workers. As previously pointed out, we are seeing the USB attached, and then also the malicious file, then some file changes available. Also, we had the security content analysis summary for the host machine executed when the host-based detection system agent started. And from here, we could drill down to the events that has been doing, so we could do a post-incident analysis of the event and the malware as well. But we won't go into those details at this point. Now, finally, if we look at the predictions, we have a custom dashboard or visualizations made for the prediction engine. Let me just put out the filters here. So we actually have the destination networks nicely shown here, the OT, operational technology, OT gates, client servers, machines. So prediction engine makes these predictions of the attacks. This will be explained in more detail by ICCs in just a moment. And I also have here a quick brief overview on the MVS tool that I was checking out for the prediction engines. So we could also include in the high-level situational awareness that what would be the best case on a specific destination network predicted based on the monitored events. So, for example, the low side, the best case for an attack to be achieved, we would have the minimum probability of 0.09, so that would be 9%, and the lowest maximum would be 0.29, and on the worst case scenario, so the high values, it would be 1, so 100%, and still the minimum is quite high as well here. So this is just that. But then on the expert situational awareness, we can also see the different predicted events here. If we look at the predictions by time, so this is also related to what high-level situational awareness was showing just a time ago. So at what point in time, what was predicted and what were the values for the lowest and highest scenarios. And also here we can see the maximum predicted downtime at different times in the network. Okay. Now, may I ask ICCS or Marcos, or who would like to tell something about this prediction engine?
Yes, hi, Yarko. This is Yorgos from ICCS. I will be presenting from Nicolas' laptop.
Okay, so would you like to first say something about this?
No, I will share my screen. Just if you could log out and let me.
Okay, so I will take this out and you can continue. Thank you.
Okay, right. So as Yarko described, basically the prediction engine results are depicted in this URL here. This is actually a tab inside the situational awareness module, which is called prediction engine. And what it does is we fuse all this information that was previously mentioned by the partners from Atos and Yarko from VTT, and we using this mechanism that and the algorithms that Marcos earlier described, we produce some predictions in terms of future events that cybersecurity events that are going to be presented in the system. Here, as you can see, there are several statistics, including the predictions like the destination network, the source network, how all these are divided into the whole distributions. And then there is the actual predictions themselves. So we provide information in terms of, for each event, information in terms of time, description of the cyber attack, the predicted cyber attack, the origin, and the relevant probability. And if we scroll further down, we also provide the time, the predicted downtime values of each event, and the respective econometric loss. These results, of course, are output of the merged information that comes from the macro and the econometric model, as was earlier described. On top of that, we provide the econometric model UI service, which is a module that is attached to the prediction engine. So for each event, the predicted downtime can be further analyzed if we click on it. And then we are directed to the econometric model web application. So as you can see from the previous slide, the predicted value here was 8 days. So this is the default value that the web service is initialized so that the original calculations are made. In the initial calculations, we account for all possible countries and all possible products, and for a market share of 100%. So we assume the aggregate results, it's the worst case scenario, let's say. So these are the econometric losses that are predicted for these specific results. But we allow the user to play around a bit, so he can choose another scenario, for example, that for less days, to select a different selection of countries of interest. So I put some random countries here, for example, and a different selection of products, and another percent, the actual market share that the company is uses. So, and clicking on submit can view the different results in terms of the econometric loss, the mean, the low, and the upper bound. Again, the user can play around with the different configurations and also input the annual revenue, the exact absolute value instead of the market share. And also we have a functionality to save the results here into a CSV file and process them later. That's all from our side.
Okay.
Jonathan, if we don't have any other showcase, I guess we can close the section.
Yeah, if we have any questions from anyone, maybe we can answer them now about the run itself. Otherwise, we can move to the next slot.
Okay, thank you guys, thank you all. We're a bit delayed in terms of the schedule, the agenda. All questions, I think it would be better to answer it at the closing session where we have this Q&A interactive, let's say, session. I think we had a clear view of the pilot implementation of the scenario, the propagation of the attack and the impacts, but also a good idea for the capabilities of the tools and their events and predictions produced. So I would suggest to have the lunch break now, but it has to be shortened. So we'll have a 60-minute lunch break, and we'll be back with the remaining part of the event's agenda. So we're back from the lunch break. I hope everyone enjoyed their lunch. We can continue now our final event. And we will proceed with in the agenda with the presentation of the macro framework and the impacts on port operations. So the floor is given to Rory from University of Plymouth.
Good afternoon, and thank you. Thank you for everybody from University of Plymouth. Hopefully everybody can hear me and see my slides. Unfortunately, due to have the commitments, we couldn't be there today, but obviously In light of that, we're here presenting sort of some of the short-term impacts on port operations sort of because of this scenario, and then presenting macro as well, which helps us understand sort of the risk that these kind of scenarios and events actually have and bring to sort of port operations as well. Sorry, slides won't scan. So this presentation is going to take two parts. The first part I'm going to present, and that's looking at the sort of the impacts of the scenario that you presented earlier, we'll actually have on port operations. And then the second part, which unfortunately, because Dr. Kimberly Tam can't be here personally, she's had to record, but will be a video that sort of speaks through the macro framework and how we use that to sort of understand the risks and impacts of these kinds of events on operations in the maritime sector. So obviously you've seen sort of the pilot scenario earlier, and sort of taking a step back from some of those, you know, from the map that you can see there on the slides, you know, Piraeus rail network actually is a sort of central artery for goods coming from China and going into Europe. The table itself there is quite small, but it just shows there's, you know, a 6 to 7 day advantage of actually bringing goods in through Piraeus and using the rail network from Piraeus up into Europe. You know, 6 or 7 days is actually quite a large advantage when you start thinking, you know, the costs of actual shipping these goods from one side of the world to the other. You know, so any form of disruption in this region, particularly one that hits the train networks directly, is going to have an impact on you know, on trade and sort of that port throughput, as well as the regional trade. I'm not going to discuss sort of the econometric impacts of that. The risk partner are going to be talking about that next. So we're going to very much focus on the operational side of the risk here. And obviously we've got an ATP, you know, that has decided that, you know, they're going to target the, you know, the port of Piraeus, you know, and obviously they've done their homework to try and make this scenario sort of as impactful as possible. And all, you know, all this kind of information is readily available on the public internet. It doesn't actually take a huge amount of work to find out sort of some of these sort of contextual sort of contextual considerations of these kinds of scenarios. You know, that's actually just a relatively simple Google search to find some of this information. So why is this particular scenario quite impactful? Well, obviously the time of day doesn't help by sort of targeting the first sort of the time that the first train will be entering the port of a morning, and obviously then derailing that train and causing disruption. That then basically blocks, you know, the port rail terminal for the rest of the day, or until the port can obviously respond and recover and remove that blockage at the crossing. The physical layout of the port, I'll show a image on the next slide that sort of demonstrates the layout and geography of the port a little bit better. But needless to say, there's this is the crossing of the road, the truck road, and the train line right by the gate. Obviously limits access for both trains in and out of the port, as well as the trucks coming and going. So yes, the port can still unload and load containers onto the ships coming in, but actually none of those goods can then leave the terminal, and they're stuck in the yard until that blockage is actually clear. We also have the issue that the size of the trains coming into the port, you know, these are several hundred meters long. You know, these are very, very long trains. They're not just made up of a couple of containers. So the problem is, obviously, once you derail at the front and several carriages along, it becomes a much harder challenge to start removing those. And obviously, with the length of train there, it means that these trains obviously stretch a long way outside of the port bounds. And then that obviously has a knock-on effect for the other trains coming in as well. And if they have to be stacked up effectively in the local region, because obviously they can't get into the port, they then take up space on those lines that then affects the other train services in the region. And then obviously part of the scenario presented earlier was that confidential information or sensitive information is stolen from the port itself. Now, ransomware is a growing threat across all sectors, but primarily in the maritime space. And while this obviously isn't ransomware directly, it can, a dedicated group could still hold this data to ransom. This data, for being sensitive, had some monetary value to the port itself. So obviously they would be interested in getting it back and guarantee they've got it back without it being spread. So obviously, you have that side of it there as well, that they could end up having that sort of data held to ransom against them. We also have the other side, that actually, if this was, rather than it being sort of sensitive information about port operations, it could have actually been personal data, whether that be financial information, HR records, medical details of staff, anything along those lines. The port could actually fall foul of the EU's data protection regulations, and there could then be a sort of further financial sort of ramifications from that in the sort of the way of fines. But obviously, the train and the crossing is just part one of that scenario. Obviously, with the secondary attack, a much larger attack happening later, obviously that has a bigger impact on the port itself. So this image, satellite image taken from Google Maps of the port of Piraeus there. The red line coming in from sort of the top corner of the image there is the train coming in from the outer region into the port. The star is obviously the crossing, and then you have the multiple lines of sidings within the terminal. And obviously you can see it's a single line in, single line out. But they share the same line. So obviously disrupting that line has direct impact on that. Now, working with our partners at the port and Pearl, train operators, discussions is that because they have the equipment there to fix the lights, the crossing lights, that wouldn't necessarily take too long to repair. It'd be removing the train that could potentially take sort of 12 plus hours to do, which would then obviously free it up, and then removing any of sort of the car, the lorry impacts as well. So in theory, the short-term impacts of the actual event would be around 12 to 24 hours worth of disruption there. But because of that secondary attack, that actually starts extending that sort of limit, that disruption into the magnitude of what could be days, if not longer. And obviously, if you're dealing with one incident and a second incident occurs, the instantly means your capacity then gets stretched, and you then have to start responding to multiple things at once and stretching those teams very, very thin. So actually this could push sort of the initial disruption for that initial attack further as well. So what can we learn from these sort of scenarios? The primary one there, that actually, cyber physical instance can have serious impacts, not just within maritime infrastructure, but actually have sort of cascading effects into the broader region as well. So these things have to be sort of dealt with holistically. Port operators and things need to be working with sort of the local region as well as national level governments to actually understand their risks and sort of come around with response plans that can respond to these kinds of incidents. Multi-phase attacks like the one presented here are becoming more popular. The hardest part of these attacks is gaining access to these systems and networks. So once an attacker is in those systems, obviously they're going to want to be able to try and get away with as many things as they can, to cause either as much disruption as possible or gain, like documents in this case, and things as well, that then they can ransom off for more money. So these are becoming much more popular. And then the final sort of lesson here is that actually, good cybersecurity practices are vital to a good response. It's the necessity of having offline backups that can be used, that are readily available, that can be used quickly and efficiently to get systems or critical systems back up and running with the minimal amount of disruption as possible. But then also it's this idea that actually we need to be upskilling not just the sort of traditional maritime personnel, i.e. the crews on board the ships or the port personnel sort of running the day-to-day. We also need to be including trained personnel that might not necessarily fall as part of the port personnel, but obviously because they are operating in and around port terminals, they can be just as impacted by these kinds of events as those in the port themselves. So quite a dynamic scenario that sort of demonstrates that actually everybody has a role and responsibility to play in the response to these sort of events, sort of trying to reduce the impacts down to as much as possible. It's not going to be possible to stop every single incident from ever happening, but with with good processes and practices in place, the consequences of those events can be lessened, which is obviously a vital part to keeping sort of the maritime sector moving, not just within your local region, but also more broadly as well. So that's it from the port impacts. So next, we're going to look at the MACRA, which is the Maritime Cyber Risk Assessment Framework developed here at UOP. It's a dynamic risk assessment model that basically is able to identify risks that are specific to vessels, cargoes, and routes, and how they change over time. I say this is dynamic. So I'm going to stop my screen share now and put on a video from that Dr. Kimberly Tam has put together for us to run through MACRA.
Hello, I hope this message finds you well. I am Dr. Kimberly Tam from the University of Plymouth. Very sorry we couldn't.
Sorry, Rory, I think when you cut your microphone, it has cut off Kimberly's voice as well.
Oh, my mistake. Sorry. Oh, start again. There we go.
And to talk about some of the work that we've done for CyberMar, but more specifically in this session, we're going to be talking about MACRA. So MACRA, very quickly, is a maritime cyber risk assessment framework that we developed. It is a way to characterize and quantify risk using a target model and an attacker. So for the last 3 years for CyberMar, we have used this model for several targets. The first was power grids and related systems in port infrastructure. It was Port of Valencia. The second pilot, we actually looked at systems in a ship, such as the steering for a large container ship, and how that could affect the wider port, so the Port of Valencia. So the ships entering the port, how can something that is digitally not connected, but in the same physical environment, have an effect? So we looked at the cyber effects of that. And now for pilot 3, we're looking at rail infrastructure, specifically within a port, Port of Piraeus this time. So those 3 together show that this framework can work for not only one type of system, but any type of target. It can model a number of complicated system of systems. And then it can model an attacker that is interested in that system. So very quickly, there are 3 parts. The first part is system vulnerability. So we look at multiple different systems. This can be IT, so information technology systems, but also OT, operational technology, which is critical for this project. So we can find a number of system vulnerabilities. This can be verified either through our project partners or through pen testing the systems ourselves, as we have these systems in the university and can verify that these vulnerabilities do exist. So the first step is, again, to look for system vulnerabilities. Again, for the first pilot, we looked for systems that could affect the power distribution within a port. In pilot 2, we looked at system vulnerabilities that could take control of systems, OT systems such as steering and navigation, so not just IT like routers. And finally, in today's scenario, which we're very excited to show, we were interested in a number of systems. The unique ones for this pilot were the rail infrastructure. So there's a number of systems associated with kind of rail barriers, rail in general, and we'll give a short view of some of those systems later on. So once we know what vulnerabilities exist, and when we know what systems exist and which systems are being included in the target model, we then try to understand the ease of exploit. Unlike more traditional kind of just accidents and incidences, cyber attacks are less about accidents, so statistics, and more about intention. If there is someone out there with the intent to do an attack, there's a higher chance of that happening. So one of the ways that we measure the intent is the ease of exploit. So from this, we can look at existing criminal organizations, existing known terrorist groups, etc. We can look at these threats, understand their resources, understand their targets, understand their resources, and from there understand the ease of exploit on how they can exploit the system. And the last part is also the reward. Why would an attacker actually be trying to do this? Because something could be easy to attack, but there is no interest in it, then the likelihood then again goes down. So the three of these together allow us to look at not just information technology, but operational technology and people as well. Because people can just as easily be exploited, which is why we also look at training as a mitigation for cybersecurity issues brought on through people. So we've also done work in that area for CyberMar, but also other projects as well. So these are the three parts. And again, today we're talking about the kind of rail and wider port infrastructure that it sits within. And that's very much in the, it has both IT and OT elements. Once you put that all together, we have these axes. So the maritime system vulnerabilities and effects, the ease of exploit, and the reward and target. So with this, we can now define what is a high risk, what is a low risk, and what is a medium risk. This is also a dynamic framework, which means whenever trigger events happen, we can then see the risks change based on those triggers. So how does this sit within the CyberMar project? So we've been working very closely with our partners at AIR so that when we have a disruption brought on by a cyber physical attack, whether that be in power, ship, or rail, we can then model how much of a delay these high, medium, or low risks cause in the throughput, and then look at the econometric loss based on that. So for the second pilot, again, this was for the ship and rudder system. We looked at these systems and decided what were the high threats and why. So we used a macro model to again look at what are the high risks and what are the low risks. Once we identified which were high and low and which ones could be affected by the attacker, we can then also vary the risk dynamically. So a dynamic risk assessment in real time if when possible, but for the Pilot 2, this was pre-calculated to kind of demonstrate dynamic capabilities. So we were able to do this to show how different triggers of cyber attacks, so different attack chains, could result in different amounts of throughput loss. So a severe incident on one system could have, days of delay, or the same system, if exploited less harmfully, could still create delays, but a much smaller one. For this pilot, we were mostly interested in the rail components. For us, we were very much interested in how this pilot was different from the others. So we took a deep dive into several of the components that make up a rail barrier and how this can then be fed in to the rest of the pilot. So we read the risk information to our partners. We had some preliminary delay times that were optional, and that was finalized by the partners, of which you probably have heard of or will hear more of. And from there, we were able to take the delay again, and partners were able to turn that into an econometric loss. So that's it from me on the macro side. So apologies again that we could not make it in person. I hope the event is going very well. And if there are any further questions, please feel free to reach out.
So there you go. That's the impacts and macro. Back over to you in the room. Thank you.
Thank you, Rory. Thank you, Kimberly, for your very interesting presentations. We can move forward with a minor change in the plans. We're going to have now the presentation about the CyberMart training program presented by World Maritime University.
Good afternoon, everyone. And thanks to all the consortium for the implementation of this project. And with my presentation, I would like to illustrate the main results under the work package where we implemented the training and awareness activities. Okay, in terms of contents, I will illustrate the challenges in maritime cybersecurity training, and after that, CyberMart training overview, final results. So, what are the main challenges in cyber risk management education? We find the lack of cybersecurity educators, a low interaction with the industry, little understanding of the labor market, outdated or unrealistic platforms in education environments, and difficulties in keeping pace with the outside world. A big challenge is to offer quality cybersecurity training. What are the reasons? Because the attacks are on the rise, more employees are working from home. Humans are considered a weakness in organizations' cybersecurity. It's necessary to provide basic training and after that, anyone can become a victim of, for example, physical attack. So, the reason about the needs in terms of training in maritime cybersecurity are that, so first of all, the studies, several studies show that the use of multiple methods of training produced the highest correlation with the perception of security effectiveness in employees. And so, with CyberMart project, we tried to implement the training as a cyber risk management approach, named CyberMart training approach. And so, the main aims of the CyberMart to train cybersecurity professionals and employees in other key areas, directly or indirectly connected with cybersecurity need to receive continuous training to be well prepared when an attack occurs. So here you can see the main features of CyberMar training approach to promote cyber awareness, to improve in the response times and specific resilience metrics, to implement a learning management system integrated with CyberMar cyber ranges. Our training are based on the NICE framework that has been designed to define a taxonomy and the terminology to describe cybersecurity roles in their corresponding competencies in terms of knowledge, skills, abilities, and go on, and to stimulate innovative cybersecurity educational approach. So, here are the main areas where we work during these 3 years of the project. Familiarization training with cyber range platform, to formulate CyberMar training packages, to explore new awareness methods, and to link our training activities and synergies with other European agencies and with other sister projects. So we implemented 3 levels in our training: the entry level with 2 entry-level training, 4 intermediate level, and 5 advanced level training, plus 1 the trainers supplied by DIA team colleagues, and 1 capture of the flag that will be held early next year. So here you can see our pathway. We delivered all the training, and so we have to deliver the last 2 advanced training and the CTF in the upcoming year. So from this slide, you can see an example of call for participants during the implementation of the CyberMar project. And so we got trainees from all over the world. As you can see, an example of the mid-level training. Here, an example of the countries, trainees countries for the advanced level. And so in the advanced level, due to an entry test, we got less participants because the skill needed was very, very high. And so in our training, we reached all the target groups indicated. And here an example, you can see the target group of composition for the intermediate to second training. And you can see a big portion of maritime officer, for example, and IT technical, and a bit also of seafarer. And so we reach a very wide kind and target group. Here, the second advanced training, the composition. And so on this slide, you can see the only one physical training that has been held in Genoa in last May. So just to wrap up the results, so till now we got 351 participants in our training. And so in terms of webinar linked to this training, we reached 102 participants for both webinar. And so in the grant agreement, we should reach almost 50 trainees. And so we are very happy of this result. As I told you before, we reached all the target groups, very wide kind of target groups, and from all over the world. And so for our training, we had the training effectiveness evaluation to get participants' opinions, and we use these to improve the quality of our training, and also evaluation tests pre and post training to measure the increasing of awareness. And so, for example, good comments that we got was the ability of the teachers, and so very clear and effective lecture. And so the aspects to improve, for example, the presence of teachers is essential because all our training has been held online due to the COVID pandemic. And so another aspect to improve, more time dedicated to this topic, and more awareness about the vulnerabilities, just to tell you something of this. So we have developed, thanks to all technical colleagues and DIA team colleagues, the learning management system integrated with CyberRange, and we are populating it with the training material, quiz, and we'll use it in the exploitation phase to offer this kind of training and some training. And here you can see some picture of the LMS. This is a kind of quiz, for example, for self-assessment. So that's all from my side. If you have any question, just write in the section question and answer, or just write me to my email address. Thank you.
Thank you, Monica. Thank you for your presentation. And I may add that in the next days or a bit more, you will see the announcement about this major Piraeus Pilot Event that will be organized for by the middle or end of January. Moving forward, going to now discuss about the econometric models and how these were applied into the project and into the all pilots implemented.
Good. Yeah, thanks everyone, and thanks for the invitation as well. Basically, I just wanted to talk about econometric model, and mainly our part to the pretty much to the most downstream part of the project, basically where we pull out the losses for the scenarios for different pilots. I think what I wanted to talk today was mainly the econometric model bit. We want to show very briefly how we built the model basically, and how we go on about the validation of the model, and also the impacts on the two different ports with two different pilots. Again, just for the basic setting, it's mainly a risk model that basically sorry. Yeah, okay. I think it's fine. I don't know. It's not really working. Oh, yeah, okay. That's not so good. So it basically captures the supply chain, the global supply chain, to estimate the losses that are resulted from certain business interruptions. So this interruption can come from any event. As I said, this EM is peril agnostic, so it doesn't really matter how the downtime of the in a particular event or in a particular supply chain is coming from. Good.
Thanks. We were sharing the others.
Good. No, thanks. So what I mean by parallel agnostic, basically, again, so I think you're going to see later on as well for validation, we are using different sorts of events to validate the model. Mainly we are using now for 3 different pilots. I think 2 pilots are for Port of Valencia and Port of Piraeus, where I'm going to show a bit of the results on that as well. Yeah. So coming to the framework of the model itself. So as you might have seen this slide in the previous presentations as well, I think macro model as well, they presented just to putting it in different modules. So I think consists of 5 different modules, where in the first step, we track the dependency of the different products. So basically where we define the industries. So we go from top level down. So let's suppose if you have a certain industry in a given country, or in this case, let's say given port, we track down from there where the material is coming from and what the material is consisting of, and then going back all the way to the tier 0 level or tier N level, where we come up with the raw material of that particular case. So you can imagine like industry is automobile industry, and then we track down to the raw materials such as glass and aluminum. In the second step, we basically define the network, how the supplier and the product flows within these tiers. In case of ports, for example, here we basically use the UN trade data. We see how the trade flows into certain port, and in case of disruption, how that trade going to impact the downstream, upstream supply chain. That's basically forms the second module where we define these networks. In the third one is basically where we calculate disruption. So basically an event happening. This also you see in one of the previous module with Makra model, where for us they provided the downtimes in terms of days, and from that mainly as an input. And in the third module, we go to the next module, which is we propagate this disruption in the supply chain based on the network that we just defined in step 2. And then eventually in the final, we basically calculate the losses in terms of monetary values, let's say. Again, as I said, the events for the disruption, they could be, it's parallel agnostic. It could be any event that can cause a certain disruption. And for the validation of the model itself, we have used these 3 events. So I think you might be familiar with the Tohoku earthquake and tsunami that was coming in 2011 in parts of Japan, and there was a port close by as well. It was heavily impacted with the tsunami, followed immediately after the earthquake. And for this event, mainly we went on first to calculate the disruption, so that coming from our more vintage model from the Japan earthquake model from our company, where we mainly model the event as more from the hazard point of view, where we go and calculate how the hazard looked like, and from there eventually comes to the disruption in terms of the BI. The BI stands for business interruption, basically. And then from there, we calculate the losses and validate those losses with different sources. They're going to show you in the next slides. And then to complement this event, we also use the Thailand and the Norsk Hydro cyber attack. So mainly to have one cyber attack scenario as well, got very popular in 2019. I'm going to show you the first 2 events, basically validation results. So I mean, you can imagine the model, it consists of a large amount of parameters. and these parameters, they need to be calibrated on certain events. Ideally, for each scenario, we would look into the validation data and sort of pre-calibrate the events, the parameters. But it really depends on how much data it is available. So in case here, what you see basically on the left and right, you see the percent decrease in the trade activity in the blue bar that is calculated from the econometric model. So again, we not only provide the mean, but we also provide the lower and the upper bound. And then on the dashed blue line, what you see is the decline in the GDP growth rate coming from a source, from the reference source. And then here, basically, what you see is how, let's say, in a way, we accurately captured the reference basically in our lower and upper bound. So on the left, what you see is the decrease in trade activity in Japan. So this is where the event happened. This is where the earthquake and tsunami happened. And on the right, what we are comparing is trade activity for the entire world. So now again, the supply chain comes into play here. How the growth rate in the Japan from a certain event impacted the growth rate in the entire world, and how the results basically again they capture the mean of what is reported basically in the. So for this event, actually, particularly we used mainly this event because we had a lot of data available for this particular event, so we could go on and calibrate most of the parameters of the model. Similarly, another event that we used to complement our validation was more on Thailand flood. Again, it was also in 2011, December 2011. I think one of the major or main aspect about this flood was, let's say, it was more in the central around Bangkok and regions, mainly the surrounding areas. They contain a lot of several industrial facilities. So there was one really good example actually of flood occurring in one place versus the supply chain for example, in car industry was heavily impacted from this particular event. So as you can see in the input itself, the automobile and components, they were affected for up to 9 days average downtime. So just give a context here again. So for 90 days, the automobile industry was impacted. They could not operate worldwide just from events happening in somewhere in Thailand. And again, what we did here is to break down different industries in different sectors, and then calculate the losses from the econometric model, what you see in the bars, for each and every industries, and comparing that basically with different sources. So here we are comparing the mean basically again by estimate from the Unistar and then the focus Taiwan references. Again, we are showing that basically you could capture in a way. So what the data we got, it is mainly for the overall, but of course it has multiple levels to it as well. From there, now what we did is basically build the model for two different ports, for Valencia and for Piraeus. Basically just wanted to bring it out the limitations. Of course, these calibrated parameters are used for these ports because we didn't get much data to fine-tune the results. But of course, as you've seen in both of the cases, and also one other, the Norsk Hydro event that I haven't shown here, basically gives indication that events from 1 day downtime till up to 90 to 100 days of downtime can be effectively modeled from the model itself. So again, for this, as I said in the third step, where you basically get the input in number of days as a disruption, that's basically the input, and that's what we are receiving from the macro model from UOP. Once we receive these inputs, we go on to use the UN trade data, where we use that data basically to to customize the econometric model for pilot 2 and 3. And the level of output you get is basically the tables, the losses in different countries, region of the world. So here I'm showing one output by the EU countries. On the left, you see the downtime of 5 days in Port of Valencia. So that's basically the pilot 2. And then on the right, you see the Port of Piraeus, again with the 5 days downtime difference. So I'm basically showing here the mean. I'm not showing the lower and upper bound, but we have that reported in the deliverables. So if you are interested, you can have a look. Basically, what we want to show the impact on different countries, different European countries, from if there is 5 days of interruption. So of course, Spain is going to be immediately impacted with 27%. Versus Greece, which is 22%. Whereas if you see it's the idea is not to compare the two different pilots. Okay. The idea was not to compare two different pilots, but mainly to give an idea on the outputs itself, mainly to show that it's basically captured the trade data quite accurately. As you can see, the Greece is more affected if there is interruption in periods. So that's one level of output. Another level of output is mainly by the industry. So if we break down the different products in these NACE categories, so you have different sectors which are impacted. And again, this is the mean results of the downtime from 5 days and how you can trace down not only different countries, but the way the trade data is coming. You can also get the interdependency between the different flows and among different sectors and find out which area or which sector would be impacted by how much. So this data here is more in percentage, but also the tool from ICS, they also have the exact numbers. So if you have that tool, you can also get out exactly the losses, also not only mean, but also the lower and the upper bound for each and every scenario that has been impacted. So I think I think just wanted to conclude mainly. So it's quite challenging mainly to obtain the data, but with the validation of different events, so 3 different events, we could quite accurately model the losses. What we've seen also that the econometric model doesn't really exhibit bias, be it the analysis for a large or a small disruption, be it global or regional, and then also the kind of the type of perils that is affected. It's also it doesn't really produces any bias in the losses outputs. The framework is ideally suited for analyzing cyber attacks, but also the different catastrophics. Any other catastrophe can also be quantified, and in the contingent business losses. What we have shown here in this case is mainly for the Port of Valencia and Piraeus. Furthermore, I think it's also the losses assist you to further understand the indirect disruptions in the maritime value chain. And also with respect to different industries, so be it the automobile, consumer electronics, and basically at state of the arts for the insurance market. So there is a lot of value added here there, where if insurance market wants to insure some of it or parts of it, they can go back and they have some data to play at hand to make educated guess on where they would like to place their policies. And of course, this is what not only industry, but also the organization, government entities, they can also leverage this information. And the idea here was mainly that they investigate they play around with different matters, with different cyber attack scenarios. So basically telling them how many days of disruption it will be caused from certain cyber attack, but then also telling them what would be the losses in terms of monetary values that will be impacted as well. from a given attack scenario. Yeah, I think that's what I have prepared. Let me know if there are any questions.
Thank you, Puneet, and that was the presentation of the econometric model. Now, according to the agenda, normally we would have a break now. However, I think it would be better if we can proceed with the presentations and conclude, let's say, the discussion about the CyberMar project by providing, if our partners from Atos are ready, to provide the presentation about the presentation of project results.
Yes, Georgios, no problem. I'm ready. So
Okay.
if you can hear me.
Yes, yes, loud and clear. Thank you, Georgios.
Okay, so I will start sharing of my screen. I hope you can see it. Let me know if you can see it.
Yes.
Yes. Okay. So thank you, Georgios, and I would really like to be there. Unfortunately, it was not possible for me. So I will do my best to make this presentation interesting, even from this distance. And if you have any question, you can stop me and ask, or you can save your question for the end of the presentation. My name is Aljoša Pašić. I'm from Atos, and I'm exploitation manager of CyberMar. I took this job actually somewhere in the middle of the project, and I think as we are moving towards the end of the project, this is also becoming one of the most important tasks in the project. So I will start with the short description of maritime sector ecosystem. As you've seen, obviously, in previous presentation, we are focusing on two subsets, two segments inside of maritime sectors, shipping and ports. We had 3 pilots. 2 pilots are with ports. One was with vessels and shipping industry, but the ecosystem is much bigger and larger. So you can see here that we put ourselves in the middle of the ecosystem, because it is, of course, this is done for deliverable, exploitation deliverable, but we are targeting different audience in the exploitation, from end users to policy makers and different authorities. So exploitation is not only about commercial exploitation. Exploitation is much wider, and this is also what I'm trying to present today. Here below you can see link. I don't know if you can copy it, Georgios, in the chat, because I would like people to enter to this link. This is a survey that is we are doing on EU pages, EU survey, and it is about the guidelines, best practices, and recommendations from the project. So we filtered from the training sessions, from pilots, we filtered some of the, and also external materials, some of the recommendations, opinions, guidelines, and we came up with a list about 20 different, which are clustered in 4 different areas, topics that you can very quickly, in 5 minutes, you can give your opinion. It is very user-friendly survey, and it would be very helpful if you can today, preferably today, but it will be also open next week to go there and to vote, to cast your vote, or to rank topics according to your priority. Okay, let's start. So specific users' perspective and challenges. The users, customers, obviously come to us and ask, okay, how much is it risk? We've seen in the previous presentation about propagation of risk, cascading of risk, that it is not only a risk for a single organization. It is it could be propagated in different sectors. How much risk increase or decrease if I spend more or less? And what is the optimal spending and investment? What is the best preparedness and awareness strategy? And then questions like if we invest in training, concretely generic cybersecurity training or specific maritime cybersecurity training, is it better? Which training is better, etc. Then also the testing, because CyberMar could be used, cyber ranges could be used for testing of different equipment and software, and customization of tools. So this is, from the user perspective, this is, I think, important to have in mind that user always want the optimal security for its investment. Having this in mind, we position ourselves in the market of readiness and assessment and readiness, or preparedness, or training awareness. It depends which market analyst you ask, because sometimes it's preparedness is everything from the training awareness, but also preventive measures that are put in place. We have also in our, as you've seen previously in our pilot, we have some detective and monitoring tools. So it is mainly, it's cross-cutting several segments, I would say. Competitors, we have obviously large global players that are sometimes do not have their own cyber ranges, but they are making partnerships. Sometimes they have their cyber ranges. We have players from maritime sectors that are entering the sector. They are used to provide safety services, and now they are moving to cybersecurity services as well. We have academic and open source, not maybe as a competitors in commercial space, but as an alternative to cyber ranges. There are a couple of open source and academic cyber ranges, for example. And we have ecosystems around specific cyber range platforms. So these are 4 types of competitors. We packaged the offering. You saw all of our tools in the previous presentation, so I don't need to go in details of each of these tools or exploitable results. You also seen that most of these results existed before the project, so they are not really results of the project, but they have been sort of innovations and integrations done in the project. So we packaged these in 3 prepackaged offerings: bronze, silver, and gold. And at the heart of all these offerings is, of course, a cyber range from DIA team and learning management system. So we have this as the key exploitable result. And regarding training, something similar happens. We have here bronze, silver, and gold, 3 offerings, which are prepackaged offering, which does not mean that we are not offering customized training and as well as customized setting of tools. What we also done is the analysis of technology readiness level, TRL, which was reported by each partner, tool owner, as well as intellectual property rights of each tool, and also for the joint offerings, which I just showed, the joint packaged offerings. So this is based on hybrid model, depending on several factors. Similar exercise was done for training. So we have the catalog of training, prepackaged trainings, and again, IPR percentage, which is assigned for each of the prepackaged offerings. In addition to these training services, we have other possible services, which are obviously not completely a product of the project, but there's some know-how can be exploited through services. Each partner acquired a know-how in thanks to the pilots and developments, and this know-how can be exploited for consulting services, for risk assessment. For example, we've shown macro and econometric model. These are risk assessment methodologies that can and the related know-how can be exploited through services. So we have kind of a scope of services in 4 flavors, I would say. Only platform provider, where cyber range can be provided as a service to other. Then platform and tool, then inclusion of service provider from the consortium, and finally we can also consider inclusion of external partner. We have also discussed exploitation roles among project partners, and how to map this for post-project exploitation. So we have a lead generator, which is usually the partner or that contacts customer. It's not necessarily technical partner. It is very likely it will be somebody from maritime sector that has good contacts. And then this lead generator can be also proposing party and contractor, but not necessarily. They can open dossier, business opportunity dossier, which is basically a statement about needs of the customer and which tools, which subset or prepackaged offering from CyberMar would be interesting for the customer. And then the other partners in the project can take role of the IP owner, which are basically tool owner, delivery partner, concert partners, which are relevant for the implementation, like system integration or some other training partners, for example, training providers. We can have external partners also. As I said, we are working also on exploitation agreement, which is a kind of a framework that is setting generic rules that are acceptable for the rest of the partners. It is different from the specific implementation arrangements, so it is not contractual document that is you can hold somebody liable for, but it's just a framework agreement that is about how much percentage, which percentage should go in which part of the or role in post-project exploitation. So you can see here that 10% of the could go to lead generator, while the remaining 90% would go to the solution, which is then split between service providers and IPR owners or tool providers. So it will all depend on a business opportunity, because some business opportunities will be, as I said, more there will be more need for customized services and for maybe consulting and this kind of knowledge-based services. And in some cases, there could be also, especially SMEs, that wants to take prepackaged offerings. Okay, I will finish this presentation with 4 key messages, which is kind of our value proposition. And it is actually mixed between value proposition and go-to-market strategy. So the first one is to approach client. We have strong references from the project. We have 2 ports and 1 pilot with vessels. So these are very good references to be used in post-project exploitation. We have, as I mentioned, we did not start from the scratch. We started from some open source tools and also pre-existing background knowledge. So there is a which reduces the cost, and there is a not really free, but we can offer some of the low-cost services, like a very light risk assessment or some training for early adopters. Targeted marketing, we know who are we targeting, so it is, I think, also very important, and use of the existing strengths, partner strengths and channels. As I said, it is a mix of technological excellence and maritime sector knowledge. Then assessment, the second step would be to assess maturity of the client, preparedness level, efficiency, feasibility, and this is has to do with what I've said. It is in business opportunity dossier. This is something that one partner usually takes that is closer to the customer, takes this role of analyzing the existing needs, maturity, performance, etc., and estimation of the cost. In estimation of the cost, is important to know if there is a specific budget limit that we can optimize maybe the offering to this budget limit, or there are very specific requirements in regard to security, for example, like operational technology, cybersecurity. The third step would be then to design offering of product as a service. This combination, as I said, of these 2 parts by adaptation to investment strategy. One is, I mentioned this, optimize security for a fixed budget, and then another one would be to have a fixed or desired security, and then to optimize the cost for that. We count on collaboration between partners. Each partner is for sustainability reasons will leave the contact post-project for exploitation purposes, and we also show the flexibility in the implementation arrangements, meaning that there are many different deployment options, many different possibilities for a combination of different tools. Finally, engagement of the customer. This is after the offering is implemented, the continuous support and feedback. Incentives, for example, for incentive management is important for trainees to get as much engagement to training and awareness as possible. Evolution and maintenance of the platform, which is again an important element of the sustainability. And we are also offering innovation workshops and assessments that are as a go-to-market, part of the go-to-market strategy. So to summarize this value proposition, we have sized and customized from risk profiling to continuous engagement. So this means end-to-end offering from the checking the customer need and maturity from SMEs to large organizations in maritime sector. Anything can be sized to and customized to specific profile of the customer. We have a hybrid delivery as a service on premises, mix on flexible offerings that can involve a number of tools in simulation layer, and not only tools that you saw from intrusion detection to CM tools, but also external tools that can be easily, with development of APIs that can be easily incorporated. We combine maritime sector expertise and cybersecurity excellence. As you saw, we have a couple of partners which have excellent record in cybersecurity, and also we have partners that have specific knowledge of equipment and software in maritime sector. Solution which is robust and providers that you can trust. Okay, so this is our let's say the value proposition. Thank you for your attention, and please, if there are any questions, let me know. I will stop sharing.
Thank you, Alyosha. Thank you for your presentation. Also, this work is about to be finalized. It will have some open issues to discuss internally and to report the outcomes. So moving forward, since it's getting a bit late here in Greece and Piraeus, we're thinking of skipping the break. I don't see tired faces inside the room. So yeah, we will continue with the presentation of the sister project of Cybermar, which is Foresight, a project funded by the same topic. And I'm glad that we have here Mr. George Kokinis from the Center for Security Studies, which is the coordinating organization of the Foresight project. So George, the floor is yours.
We try to get it fixed. We have some bad news. We also have good news. Shall we start with the bad news first? Bad news, it is Friday. It is kind of late. I know you have a really tiring day. So, and actually the bad news is that my slide is somehow around 34 slides, my presentation, which is a killer. Now the good news. The good news is that after the presentation of SIM from Atos and the presentation of SIM from the guys from Sweden, the World University, I think we have very much in common. And actually some parts will be really, really common to you. So I'm not going to break any ground, so I'll disseminate something new. So let's go briefly, okay? More or less something about our project, because you might be not aware of it. We're on the same call. We have, let's say, more partners. We're 22 partners from, let's say, 9 EU member states. We also had 6 months extension, which is the end of our project is going to be end of March 2023. And we also have together some limited interaction around 11 months ago. Some of you, I presume, you know about our motivations, our goal, our objective, which more or less is the same. Basically, something that you have heard quite a lot of times today is that in naval, we call it naval, you call it, maritime domain, we have a strong need for skilled personnel, and that should be aware of cybersecurity. Somehow this is not happening. So security skills will have a shortage, and above all, our top management is kind of cyber aware, not literate. So they're quite naive about what is happening outside. So if they found the USB dongle outside in the parking lot, they will be happy. They will, stick it in the company's network with all these consequences. So basically, there is a need to find some really trained personnel, although training is not there. So our project is more or less focused on training. So basically, we're going to go a bit quick on the slides. We also have a federated cyber range. Foresight has 3 cyber domains. We have naval domain, we have aviation domain, we have power grid domain. So we have 3 cyber range, and each one is focused on each domain. We also have, as I said, a naval domain. So we also try to have some domain-focused scenario. That means we also have some scenarios that focus on the maritime domain. We don't focus on port, we focus on ships either on a dry dock or ships on the open sea. And we also try to find some, let's say, hybrid scenarios, because ports, aviation, and power grid are all part of the infrastructure, critical infrastructure, and all of them are connected. So in our project, we're trying to find consequences between an attack starting in the ports, in the naval domain, going through aviation, and then going to the power grid and see what will be the consequences there. So more or less, because we're on the same call, we have the same objectives. So I'm just going to skip it out, and let's focus a bit more about methodology. So as every research project, we started with the requirements. From the requirements, we define the architecture, and then we're developing some tools, which of course you've done it as well. And we also have developed some training materials. And the Foresight project, we pay more attention and more effort to develop this training material. And of course, we have some validations. And by the way, congratulations for having so many people engaged in your pilots. We have, I don't know, a few of them I can remember all by the first and the second name. So congratulations for having many users. So the high-level concept, as we said, we have 3 cyber ranges, all of them are connected together, and our remaining focus, it is on the cross-domain exercise or scenario. So an event that will happen from the aviation will go from the power grid to a naval domain and see what is happening. To do that, we also have a complex system with assets spread all over around Europe. So we have 3 cyber ranges, 2 of them in France, 1 of them in Estonia, and we also have some training environments. I don't think we have some training environments. It's a kind of what we call a lightweight version of a cyber range. Kemea's a lightweight training environment. It's like capture the flag. So basically people, they can have some training material, some training content, and then if they're confident, they can have as a team or as an individuals go into training material to see if they can capture the flag and get it there. And actually the training, it is like the core of our focus area. So we have some learning modules, and based on these learning modules, we have a gamification module to have some, let's say, user interaction, and also we have some competition modes. We can have, let's say, blue team, red team, we can have purple team, we can have briefings, and we'll try also to have inject some useful intelligence. Most of them are coming from the CTI, and also have an analyzer. But going more into training, we have seen that we're focused on the individual skills, because as we have said, and you all agree, I presume, that people working in this domain, they need more training. We also focus on team skills, and we have developed some collateral material and some joint exercises where people should combine knowledge together and react, and also other skills. And other skills in our areas, because we're dealing with cross-domain, that means some soft skills, which some people working on the cyber defense, they don't actually have them. So this is what we have done. Unlike EU, because I think we have 3 levels in the naval domain, we have 2 levels in the naval domain, and we have, let's say, 7 modules. We have a beginner level and the intermediate level, and that's it in the foresight. In the power grid and in the aviation domain, we have, let's say, 3 levels: beginner, intermediate, and advanced. And we also have, let's say, something like that came as a bonus, some generic path, because some people, before they enter the basic training, they have basic skills. For example, what might be social engineering. So we have developed 7 courses with 34 modules that will assist some people to get some insight about the cyber risk. And as like you, we have also followed NISA recommendations. Our training is focused on European credit transfer and accumulation system. We work quite a lot on this trying and also on the ECVET system. And actually, at the end of each course, we have some credits corresponding to hours, also to the degree of difficulty and how things like should happen. And also we have some renewal policy based on industry standards and recommendations. And we have also make some rough estimations about cost, how much it will take for someone to train using the foresight system. So basically, naval domain, and this is an overview of the courses. But before we go to the overview, we have seen that the competencies more or less are focused on the web security, network security and software, malware analysis, digital forensics, web Internet of Things going all around the places, reverse engineering and cryptography. And all these technical competencies are mapped into 7 modules. And we call the first one basic concept of cybersecurity, which is actually basic and generic. Then we have a more focus with the cybersecurity in naval domain, ship and crew cybersecurity, standard operating procedures and best practices, risk assessment, basic concepts of cryptography, digital forensics, and network analysis, and some maritime cybersecurity applications. And we have some critical thinking, which is essential at each module which the trainees will develop, and also some analytical skills at the end of the training these people should demonstrate in order to advance to the next course. So basically, this is the outline of the naval domain. More or less, it's kind of 40 hours. And at the beginning, before COVID area, this approach is supposed to happen physically. However, this was not happen. By the time we give the training, it was still on COVID and on our travel ban restrictions. So we have to make this content more or less suitable for e-learning. So apart from developing the content for a physical delivery, we have to deliver this training also to be an e-class and actually be synchronous or asynchronous. So at the beginning, we were hoping that we will have, let's say, locked in this room, 10, 12 people from 8 to 5 and ask them to do the training and spend some more time. However, this didn't happen. So we have kind of e-learning material, asynchronous, so people, they can have some, let's say, hours of their duties, or at the evening, they can go to the home and do some training. So roughly this, I'm not going to repeat all of them. We have some learning outcomes. Each basic training has some learning outcomes. And at the end of this module, we also ask users if they're familiar with the learning objectives. For example, the basic ones to have the confidentiality, integrity, and availability, the IAAA knowledge, and some security versus safety. So we start very easy. So we also expect at the end of the course to develop some analytical skill and develop some critical thinking and also do some exercises together because they need to pass an assessment if they have to move from this course to the next course. So the assessment mostly composed from questions that was multiple choice questions that the students they have to answer in the learning management system. In some courses, we also have some, let's say, virtual labs where the students have to attend the process or they have to log into a training environment and try to capture the flag or respond to a challenge. And each course has its own unique, let's say, skills, critical thinking that should be developed. And actually, at the end of the course, we also try to do an assessment about the course material, an assessment also about the learning experience we provide them, either in the Moodle platform or the access to the cyber range or to the training environment. In our cyber range, a part of the pilots, we also have this opportunity to have this training material, which is also for academics and university professors that didn't have, this opportunity to do that. So usually they teach about that, but the cost to have a cyber range for officially booked and do an exercise cost of money, and universities that don't pay. So actually, instead of having students from the industry, we have more academic professors who really enjoy the training and ask a lot of questions. So this is what is happening for site. We also have some standard operating procedures and best practices. And also this course, this module finalized this domain, the beginner domain. We have 3 more courses for the advanced domain. And at the end of the courses, this is where you guys have been done better than us. I have to admit that, George. Congratulations. We only have, let's say, 12 users engaged and registered in the system. However, during the training pilots, 9 of them actually managed to interact. Some of them, they give up really early. Some of them, they fail some exams, but they retake the exams and they continue afterwards. So more or less, because we also have some certifications out of the naval domain and the 7 courses, 3 users achieve the first domain, the beginner domain, and 2 users managed to go to the higher domain and have what we call it intermediate cybersecurity certification. And also we have, as we said, some basic concepts. And this kind of the syllabus, there are 34 courses, and each course has its own unique, let's say, slide deck, some training notes, and also a unique set of questions. So everybody that attempts this course, if it is a questionnaire, has to pass this with a rate above 70 and has to finish this course within a certain period, and also there is some prerequisites. If we have something like a more advanced and demanding course, like cryptographic applications, then these people, they are part of the quiz, they also have a hands-on experience, a virtual lab. That means they have to go to a training environment and demonstrate their knowledge there. So in some other courses, they also have the opportunity for the students to either team up as a blue team or as a red team in the cyber range. And this is also has to be arranged because we need to have some trainers available to guide the students and offer them some examples and actually rate them. So this is what we have seen, and these are the courses. Actually, with my thing, guys, to write a book about or a journal about this training, because we have many similarities. And also we can, let's say, have some common findings as far as I've seen, because I've seen all these pilots. So more or less we are here. So if there are questions, feel free to send an email. Not accepting questions right now because it's Friday and we want to go home. And thank you for your attention.
Thank you. Thank you, George. And Thank you for your nice words about Cyberman, but I have to admit that you have also done great work in terms of training, as it was presented today, and really nice presentation. So I have also to say that based on the discussions we have, we'll have the chance to, at least for the remaining months of both projects, to have some more common activities in presenting and discussing our findings, either for training or for the technical developments that took place. We're approaching to the end of the event. So if I can share my last presentation, not actually presentation. Okay. Okay. So as a final session, let me summarize what we have seen and discussed today. We had the chance to talk about general stuff about cybersecurity in the maritime domain. Some facts presented the motivation of our work, but also we presented the main concepts, the objectives, and the main results both from Cybermar, but also from the Foresight project, which are sister projects in this domain. A major part of the event was the demonstration of the Cybermar Piraeus Pilot, the final pilot of our project that included the testing and validation of the final version of our platform through the simulation of complex cyber attacks to the port container terminals infrastructure. We also presented the impact of such attacks to the port operations and also the wider econometric impacts in terms of business disruption and associated economic losses. And we elaborated both on the Cybermar training program for cyber skills development and also the training program from the Foresight project. Concerning Cybermar, the remaining activities of the project include as I mentioned earlier, the implementation of the Capture the Flag challenge and also 2 more training sessions using our platform in January, and the finalization of the dissemination and exploitation activities and some preparation of the necessary reporting. So having said that, we can go to any questions that may have been posted in the chat. Okay. Okay, we don't have any questions posted, although I have to say that we have a full book event, I was about to say, today. I hope that the presentations were interesting and not boring or tiring. It's indeed Friday evening. So that was the project's final event, the Cybermar final event. I want to thank PCT for hosting in this nice room and the very premises the event. Also, I want to thank our partner Civility for organizing the event, our partners for joining, for presenting their work, and also colleagues from the Center for Security Studies for presenting the Foresight project, and all of you for attending this event online. Just to remind you that we have circulated in the chat the links for either evaluating the pilot presented today and our presenting the recommendation and guidelines. And I want to encourage you to follow us in our social media and stay tuned for more information for our project. Thank you very much, and I wish you all a nice weekend. And see you soon.